All right. Well, Sean, if you can hear me, I don't know if you can. I think my mic's working now. I can hear my voice when I do the sound check. What I was hoping tonight, the very last minute, is that we could take on one of these challenges. If we go to the curriculum, you can walk through all these on this screen here. You can walk through all sorts of different things. I've dabbled in the responsive web design certification and the JavaScript. I'm almost done that. Excellent. I mean, there's a lot of really cool stuff and they keep updating everything. But these are almost as if you want to get a certificate. And each of these little challenges, it takes about a minute or two. Maybe one day we could do a marathon. And I remember there was an individual, I forget his name, but he basically went through the entire curriculum over a weekend or over a week. He just, did a marathon, bang, bang, bang. Would it be good to learn Python? I think so. I mean, that's up to we could tackle on data analysts and with Python or scientific computing with Python. Python's becoming just more and more popular, especially with data science and that. It's okay. It's good to be a beginner. So yeah, I haven't tried any of these. They sound like they'd be a lot of fun to learn. So we could jump into one of them. Or we could try taking on a challenge here. This is as if you were going to go for an interview. They sometimes have these coding challenges. And these are kind of standard questions they ask people, apparently, during an interview. They'll say, code me up these different challenges. So we have some options. We could learn Python, or we could try to take on a challenge. I think Python would be kind of interesting. As much as I like, okay, good. Nobody in the waiting room. As fun as it is to take on a challenge, sometimes it's, I don't know. It's not for everybody. So we can do this one, scientific computing with Python. So these are like introductions, so a lot of documentation. And I'm wondering if there's a project we could chip away at. Scientific computing. It's almost like you have to build up to the projects. So yeah, we can try to, there's 56 of these lessons. What we'll do is we'll just start going through them one at a time. This is supposed to be like a study group. So we'll just learn together. If you're all right with that, Sean, you cool with that? It's just the two of us. So. I should have advertised this evening a little bit better. Of course. All right, cool. All right, man. It's you and me. All right, so Y program. Here we go. And here, before I kick this off, I wonder, I'm going to stop sharing. I'm going to share again, but I'll add some screen sound. Yeah. So we'll see. Let me know. I'll open up the chat here, Sean. Let me know if you can hear the video all right.
Hello, everybody, and welcome to Chapter 1 of Python for Everybody. I'm Charles Severance. I'm your instructor, and I welcome you to this class. The basic goal of this class is to teach everybody how to program, regardless of your background. You don't have to be a math whiz. You don't have to be a computer expert. No matter how old you are.
Can you hear the video right there, Sean? I'm just going to speed up a little bit so we're not here.
Or what your background is, we want to teach you how to program. So welcome to the course. Welcome to Chapter 1. So the first thing to understand is that the purpose to learn to program is because computers want to do things for us. They are built and created and designed, and their hardware is set up so that they basically ask us, what do you want to do next? If you grab your phone sort of does nothing until you tell it what to do. It waits for you, and it's just waiting for you, and all the hardware, computer technology around you is generally waiting for you. And we can use this for useful things. We could play video games. We could have it help navigate for our cars. Someday we might even have self-driving cars. And it's really, in a sense, in my mind, silly if you spend your whole life not really understanding this technology. And I think it's important that we learn to tell these computers what to do rather than just let them increasingly control our lives. And so, as we'll see, computers aren't very smart on their own. We humans are the ones that imbue them with knowledge, but we need to learn to speak their language. It is much easier for us to learn to speak their language than it is for them to learn to speak our language. Although, with these cell phones, we're starting to see little bits where they can begin to understand, but you would be amazed at the 40 or 50 years that it has taken us to understand, how to build programs to begin to understand. So, I'm bringing you into something where you are going to learn the ways of programming and the ways of the computer, because it's easier to teach you how to program than it is to teach this how to work in your world, even though ultimately the goal is to get this to do work for you. So part of what I'm trying to do is move you from a user perspective, where you just look at the computer as something that someone else has constructed and you are the user of, to the point where you construct new things. Now, the first kinds of things that you're going to construct are actually things to solve your own problems. And it's very popular now to work on data, and Python is an excellent programming language for data mining and data analysis, and that's a lot of what we're going to do in this course, although really it's a gateway to all kinds of things like, artificial intelligence or gaming or navigation or mobile applications or entertainment, all kinds of things. But first we have to learn to program. We have to move from using the computer as a tool to using the tools within the computer that allow us to change how the computer sees the world. So there's a couple of reasons that you might want to be a programmer. Some of you are looking to improve your career, to be paid to work on programming. I've been a paid programmer most of my life, and I like it. It's a good job. You don't have to stand in the mud. You don't have to lift things. You have to use your brain. And I'll just say that it has been nice for my career to not be exposed to the elements, but to be able to work often wherever I want. But that's actually our secondary goal. Our first goal is to get you to write programs that solve problems that you have to solve. Maybe you have a job as an accountant or a lawyer or something else, and maybe you run across some data. Maybe there's some system that logs your time, and it's not quite giving the report that you want to give. And so you say, could I just grab the log data myself and write a program to do some analysis to say, oh, what's the average this versus that, or the average of some other thing, right? And so that's the basic idea, that you'll initially use computers to serve your own ends. That makes it a lot easier to write programs because you don't have to worry about a million users using your software. If it works for you, then we're happy. And so it takes a little more training to write software for other people or for thousands and thousands of other people. And so part of what I want to do is I want to change your perspective. You look at this from the outside and you see it from the outside and you click on things. I want to turn this around, and I want you to be the person inside this looking out at the world. And as a programmer, we are making things inside these computers for the world. And so we want to pull you into being part of this. We want you inside this, or thinking inside this. And what you learn is that if you're inside this computer and you are taking your instructions to build programs to be used by the human, the human outside the computer, you have things that you need to take advantage of. There's things like the central processing unit, the memory of the system, the network connection of the system, the disk drive or permanent storage on the system. And as a programmer, you are kind of mediating between all those internal resources that this has that are not very smart but highly powerful, and mediating with what that user wants, right? And so we take the end user, and we programmers, we serve the end user, but the computer serves us. So together, between us and all the computer's resources, we can serve the needs of the end user. And we do this by writing code or programming, okay? And what is that? Well, programming is a sequence of instructions where we are giving instructions to the resources inside the computer in a way to accomplish the goals of the end user. And remember, sometimes we are our own end user. It's not just you're not always doing a startup. You're not always writing a mobile gaming system. Sometimes you're writing something for yourself, but that's okay. So sometimes you're writing something to solve a problem. You're like crafting. You're doing something that you could do by hand or manually, and you're making some clever little 25 or 100 line program, and you're putting that in. Other times, like when I work on the open source learning management system, Sakai, it is my creativity. I've got an idea and I want to share it with a million users, and so I write my code for an external audience. And so code is that sequence of instructions that the computer itself doesn't know how to hand a roster out, but I can write code that will hand a roster out by looking at the data that's inside this computer, inside this application. And so if you think about programs, we have programs for computers and programs for humans. And a number of years ago, sooner or later this will be me showing my age, this is an example of the Macarena. And the Macarena is a song that effectively is a sequence of instructions. You put your left hand out, you put your right hand out, you put it on the shoulder, you wiggle, 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 and you spin around and you do things. And this is a program for people, and so I want you to take a quick look at this and see if you can find anything wrong with this particular program. So look really closely. So I'll show you.
No idea.
It's got some typographical errors in it, and we as humans are really good at reading or hearing typographical errors and correcting them automatically and instantly. And but computers are not. Computers are extremely literal. If it saw this ham instead of hand, it would think, what's a ham? And why am I going to hit someone in the back of the head with a ham? And why would I take my left hand and hit somebody? That's, these are all bad things. But the computer is going to take us very literally. And so we have to be really precise. And the computer just doesn't know the difference between what we mean and what we say. So we have to be very precise. And this is one of the great frustrations that people have when they first start using computers. And so we have to get this right. We have to get these little bits of text exactly the way they are. Computers will blow up with syntax errors, and they seem to make quite a fuss when you make the tiniest of errors, but you'll get used to that. I mean, that's not because you're bad or you're less than awesome. It just means the computers can't compensate when you make small mistakes. And so you got to get used to the fact that the computer is sort of intellectually not as strong as you, and so it gets confused really easy. Even though when it gets confused, it says seemingly mean things to you. So you'll get used to that. Okay, so the first thing I want to do is I want to throw up some text, and I want you to, while this text is up, I want you to count the number of each word in this text and tell me what the most common word is in this text. Okay, so here we go.
No idea.
Okay, so I kind of made that hard on you on purpose by moving around and distracting you and confusing you. But even if it's not moving at all, it's a little bit, tricky to do. You probably stare at it a couple of times. Your brain is going back and forth and back and forth. And so text analysis is one of the great things that computers are very, very good at. And some of the things that, they can translate text, and that's because they've looked at a lot of information. So looking at text is actually something computers are really good at. And so if we take a look at the kind of programs that we're going to write to do this kind of thing, this is something that humans are not naturally good at, but computers are super good at. Now, I'm not going to have you look at this code. This code you'll understand in a few weeks. But basically, this is a set of instructions to open a file, read that file, read all the words in the file, create a histogram of all the words in the file, and then search through that histogram to find the most common word and tell us what the most common word is in the file. And in this clown file, the word the is the most common. It happens 7 times. And here's another large file called words.txt, and the word to is the most common thing. And our goal is to get to the point where you can write this on your own. So you can say, you know what, I got a problem to solve. That is, what's the most common word in this file? I know how to start, and then I know how to finish. I know how to do the stuff in the middle. And we have to learn this kind of weird language. But when we do, we can count millions of words as easily as we count 20 words. So that's the fun of all of this, is to teach you this language so that you can solve that problem so that you don't have to solve it. Because you could solve it, but it's not something that you're naturally good at, and it's hard work. So up next, we're going to talk a little bit about the hardware architecture that you're going to be experiencing as you write programs.
Okay. All right. So very intro. Who should learn? Okay, here's the answer here. Everyone. Correct. Okay, so we're done our first challenge. All right, so here's the second challenge. I wonder how long this video is.
Hello and welcome back to Hardware Architecture. Now you might ask, why do I tell you about hardware architecture? Probably you're not going to build any hardware, although it's fun stuff to do. And if you're going to become a computer scientist, which most of you won't want to be, it's a great thing to study. And those who build our hardware are amazingly talented individuals, and it's a really rewarding job. The reason I like talking to you about hardware is because I want to be able to use words at some point and say, oh, secondary storage, or central processing unit, or random access memory, or peripherals, input devices. And I want to be able to say those words, and I want you to be able to understand them. And so I'll start with a little piece of hardware called the Raspberry Pi. And Raspberry Pi is a cute little single board computer. As we go forward, these things are smaller and smaller and smaller. And the interesting thing is that the architecture of these stays the same, but the number of components drops. So I'm going to start and give you a block diagram of sort of a generic computer and tell you the major parts of it. Now, I'm going to show you some really old hardware, some really new hardware, and then some hardware that is of medium age. And the medium age hardware is probably the easiest one to see. The architecture is the same, okay? And so the basic block diagram is that the brains, if there are brains in computers, which there really aren't, the software is the closest thing computers have to brains, but in hardware, the closest brain the computer has is this, called a microprocessing unit or a central processor unit. And this is designed, 3 billion times a second to ask the question, what do you want me to do next? And these little pins on the back are our instructions, like 32 or 64 of these pins, 3 billion times a second, we send an instruction into these things. Now, we can't sit there and talk to it. We can't. And so the instructions we store in what's called the main memory. And this memory is really fast. And the memory sort of feeds this. And so every time the CPU needs a new instruction, it asks the memory where that instruction is. And so the memory feeds the instruction CPU. CPU does it, says, give me another instruction. CPU does it, gives you another instruction. And that is the basic essence of programming. This asks what's next. And this is where your program is stored, or a program you purchased or came with your hardware, where that's all stored. And those are your places. And so you end up inside, your programs end up inside this memory. So then there's, and so in software, you tend to program the CPU. And if you had bought a desktop computer a number of years back, it would have this thing called the motherboard. And the motherboard is called this because it kind of connects all the components together. And so if you buy memory by itself, it does nothing, but it has a place to plug into the motherboard. And if you buy a microprocessor, it has a place to plug into the motherboard. And if you buy a hard drive, this is a really old hard drive, it has a place to plug in on the motherboard. And so the motherboard sort of connects everything together. The hard drive is secondary storage. Now, the way how secondary storage is different than the main memory, which there it is. I got unpile this stuff. So this main memory is really fast, but as soon as you turn the power off of this memory, it sort of vanishes. And so to store files like word processing files or text files or whatever, you got to store it on something that lasts a little bit longer. And so that's the purpose of the secondary storage. It's permanent. When the power's off, it stores it. Now this one here is in such bad shape that isn't probably storing anything, but it's got these little heads and it spins around and goes in and out. And we'll have a video later that shows you one of these things that's not quite in as bad a shape. If you look, this has 4 different platters that are all spinning around. And so this is just using magnetic material and electronics that sort of magnetize and demagnetize this stuff. And if you look at a disk, they're often rated, physical disks are rated in revolutions per minute, and that's how many times this thing spins around. If you got an old desktop and you hear it spin up, this is the thing that's spinning. And it's the place that your operating system lives, your files live, your applications live while they're stored and while the computer's turned off. And then they're loaded into this while they're running. And then this CPU takes the data from the main memory, and your program runs at 3 billion operations per second. So let's talk a little bit about something that this is probably from the 1960s or 70s. This actually has, if you're an electrical person, has capacitors. Those little silver things are capacitors. These little colored things are resistors, and that's more capacitors. And then there's wires. And wires move everything. And so when you say like this has millions of transistors, oh wait, that isn't a capacitor. That's a transistor. That's a transistor. When you say that this here has etched, and if you look closely at this, go look at a picture of a microprocessor online, you will see that it has millions of these. And so the difference between 1960 and today is this circuitry of capacitors, resistors, and transistors has been microized and put onto this. It's using a photographic process, and they're tinier and tinier and putting more and more on. And if you think going from millions of these to one of these is crazy, the thing that's happening now, and the reason we have whole computers inside our pocket, is that everything, all of this whole thing, CPU, memory, everything, all of it connected, and the storage is being made smaller and smaller. And so this little single board computer called the Raspberry Pi has one thing in it. It has the main memory, and it has the CPU. It has connections for things like peripherals like keyboards and stuff. Now it doesn't yet have secondary storage on it. The secondary storage gets plugged in right here via USB. And then if you take it one step farther to my phone, it's got the secondary storage built right in. And so, you know, this picture goes from the size of cabinets in the old days all the way down to really tiny. But at the end of the day, inside it is a highly sophisticated piece of circuitry that asks for instructions one at a time, and main memory that holds the instructions and feeds them. Okay, central processor does the thinking. Like, look here, central processor does the thinking. It runs the program. It's asking what's next. It's not really smart, but it's really fast. And so we compensate for the lack of intelligence of this thing by us writing really good software that runs really fast. And so voice recognition on things like phones is possible because computers have so much storage and they run so fast, and the algorithms that do voice recognition are finally starting to work. Input devices like keyboards and mice and pens and whatever, they come in. Output devices are like the screens that we see. The main memory is the fast part of the computer that stores all the programs, and the secondary memory is the permanent storage. Increasingly, secondary memory, do I have any USB sticks in here? I don't. Well, increasingly secondary memory is flash RAM or static RAM with no moving parts. And so you, in a few years, you'll not even be able to see secondary memory with moving parts. But that's okay. It's still secondary memory. It's still memory that lasts. And so you, and where your place is in here, is you live in the main memory. This is you. You are here. And so, in a sense, when the CPU asks the question, what next, it is your job to answer that. And you answer that by writing Python code. And so your Python code, you'll write a file in Python code, blah, 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 blah. And then that Python code sort of gets loaded into main memory. There's a magic translation process that happens. And then your code is actually answering this question 3 billion times a second. 3 billion times a second, you're sitting there. But this is you. You're really out here, but you then write a file, and the file's loaded in, and then the file runs. And that's how things are at. And that's your place in the world. Now, what's actually running is not Python code. There is, as I said, a translation process. You write a Python file, and then Python itself translates this into the actual language known by the microprocessor, which is a series of zeros and ones called machine language. Someday I would love to teach you a class on machine language. But for now, we're going to teach you Python, and we're going to use Python as a crutch. We don't have to talk machine language, but you could, if you really wanted to, you could know how to write machine language. But I assure you, Python is far easier to learn than machine language. So Python acts as a translator, translates what you're doing into machine language, and then machine language is what's sent back and forth. But still, even though it's translated to machine language, it's you. It is you answering those questions, and that's what a program is you pre-storing your response to the what next question over and over again. So here's a couple of videos that you can look at on YouTube about a CPU. These CPUs, and look very much like the CPU that I've got with me, these CPUs have extremely high heat. When you put this thing on your computer on your lap and it starts to heat up, that means it's thinking really, really hard. And so this is a small little old video from a long time ago that shows what happens when you take out the cooling capability of microprocessors and just how hot they can be. And the other video that I have is a hard disk, something like this hard disk that I have, except that it works and they turn the power on. Some of them last for a few seconds, some of them last for a few minutes. It's never... I must be allergic to this hard drive. Or maybe it's because there's dust in this hard drive and I keep spinning it and I sneeze. But basically, some of them last for a few seconds, some of them last for a few minutes. It's not a good idea to open them up, but I'm glad somebody opened it up and then did what they did and then recorded it so we can all enjoy what it is that they're capable of doing. Okay? So that's a quick introduction to hardware, mostly so that I can use those words going forward. Now what we're going to talk about next is communicating in the language Python. That is, writing code and putting it into the computer so that can execute. Okay?
Wow. All right, we're chewing through these videos. Usually I don't watch these videos anymore. Some interesting things there. Probably relevant to you, Sean, Mr. Electrician, talking about capacitors and stuff like that. You notice like he has an old school monitor in the back and, oh, sorry, let me get the chat. Yeah. And he kept talking about the hard disk or the secondary storage. Those spinning plates, that's kind of old school now. I mean, we have usually solid state hard drives. You have to pay a little bit more for solid state hard drives, but I mean, it makes a world of difference. So it even just goes to show you from the time of when he made that video to now, things have changed. Okay, so where are your programs stored when they are running? They are stored in memory. So we write them. My Mac is quiet because of, yes, solid state drives. That's correct. If you ever use anyone's old laptop, and especially if you try to like update all the software and you hear it ticking, like that's what you're hearing. I mean, you could go back and watch some of those videos he was sharing, but basically that's what you're hearing. You're hearing the plate spin and you're hearing that arm go back and forth. Now, the no-brainer is that over time, those hard drives that actually have moving parts that spin the plates and move the arm back and forth all magnetically, they're going to wear and tear one day and they're going to crash. And so it used to be a joke of, what's your backup plan? If you don't have one, like, it's going to fail one day, right? Solid state, I think, has a little bit more lifespan. I don't hear too many solid state drives crashing because there's no moving parts. It's almost like you've taken, I don't have it handy, but a USB stick, and they've blown that up into like holding, you know, a terabyte or half terabyte or what, how many gigabytes you have on your hard drive. But yeah. So how are they with heat? It's a good question. I think that's not bad. Solid state drives. Obviously, if you're doing a lot of work, that's a good question. I don't know. I'd be just speaking out of my ass. I know what he was showing, that other video, the CPUs, they are notorious for heat. So that's, if you crack open any computer, you're going to see something. You're going to see a heat sink, or you're going to see a fan. So they usually use a combination of either some kind of heat sink with different metals to dissipate the heat, or they'll have a fan glued onto it. What is a CPU and what's a, good. So a CPU is a central processing unit. So it's this one here. A GPU is a graphical processing unit. So when the video gamers started to make these video cards more powerful and immersive, they actually had to put a bigger processor just for the video card, because the video game had so many like graphics and so much going on that they needed almost like a separate computer just for the graphics. Now, here's a little interesting thing that you've heard out and about, is that people realized that rather than just playing video games, you could line up a whole bunch of these cards and use them to mine Bitcoin and cryptocurrency. I have a buddy, he does that. He has like a little rig in his living room, and it's just, it's an old computer, like one of those old motherboards that he showed. And he's got like, I don't know, 7 or 10 GPUs, and those things aren't cheap. Like a card usually goes for a couple hundred. So I think he bought used and kind of swapped here and there. So he got 7 of these bad boys, and he's got this whole rig and setup. It was actually kind of neat how he showed me how people are kind of mining cryptocurrency these days. He does not Bitcoin, but the other one that's popular, begins with E. I have a Jetson Nano, and it has a GPU, but the Raspberry Pi has a CPU. Thank you for clearing it up. Yeah, no worries. So yeah. Okay, so the answer for this is memory. In crypto? No. It was crypto. There it is. Ethereum. That's the one that my buddy, he said Bitcoin, because Bitcoin is so popular, he said basically you would have to own a data center to make money now. When it first started out, people were using GPUs just in their bedrooms to make money, but it's become so popular and so almost concentrated that, yeah, you need almost a building with multiple floors of computers just to make a bit of money. This one, he says, hasn't got to that point. It's starting to tip over, but right now, people can still make money with this currency. And it's the second popular cryptocurrency. And that's it. That's all I know about cryptocurrency. I'm tapped out. All right. Memory, I think, is the answer. Ding. I got lucky on that one. Not really lucky. Okay, here we go. I think there's only a few more videos. Are you okay with watching these?
Hello, and welcome back to Python as a Language. You'll notice that I'm wearing a hat. Part of the story of the hat is that where I work here at the University of Michigan School of Information, my office is in this building called North Quad, and we call it Quadwort sometimes because it's sort of got a square that sort of imitates an Oxford quad. And so it seemed to me to evoke notions of Harry Potter. When we first moved into the building, I joked in one of my classes that we should have a sorting ceremony for all the students as they come into North Quad for the first time. And so that was cool, and I thought that I would belong in Gryffindor, like everyone wants to be in Gryffindor, right? They're the good guys. And my students told me that I couldn't be in Gryffindor, that I had to be in Slytherin. So you'll see me drinking tea throughout the course of this teacup. It's my Slytherin teacup. I picked that up from Harry Potter World. I went down to Florida and visited Harry Potter World. And the reason that I am was sorted by my students into Slytherin is also because I teach Python. And Python is like a snake. And so if you think about the people from Slytherin, they are capable of talking to snakes. And the class that we were doing the sorting was a Python class. And so it sort of made perfect sense that you would have to be in Slytherin if you were the Python teacher. And of course, your name is Charles Severance. And then that sounds kind of like Severus Snape. And so I just accepted that I'm in Slytherin. Okay. So you all can be in Gryffindor, but I can't. I'm in Slytherin. So I'm the bad guy or the good guy. Depends on how you look at it, right? And so what I'm going to do now is I'm going to, bring you into Slytherin as well, because I'm going to teach you the Python language. Python is the language that we Pythonistas talk. It was invented about over 20 years ago by a fellow named Guido van Rossum. And away we go. Now, even though I'm using this whole snake Slytherin thing, it turns out that Python was not at all named for Harry Potter, because Python was invented, almost 2 decades before Harry Potter was created. And it wasn't for the snake. It was actually Monty Python's Flying Circus was the inspiration for Python, the name Python. And because Guido van Rossum really wanted to create a programming language that, while it was powerful underneath it in its very nature, was a very powerful language, he wanted it to be a language that was fun. And he wanted it to be a language that was approachable. And so that's why Python recently has become so absolutely popular. And it's easy to learn, but it's also powerful. And that's sort of the magic of Python, is the ease of learning it, the brevity of the programs, the shortness of the programs, and power. And so we are going to become Pythonistas. Now, as you learn to be a software developer using the Python programming language, you are going to encounter syntax errors. And I remember when I used to get syntax errors, and I remember my first programming class, and I would type on cards. And I would upload those cards to the computer, and the computer would say, "You're not worthy." And I'm like, wait a sec, those are pretty good cards. How could you be so critical of me? I'd say syntax error. And I really got sort of a really bad attitude that somehow this computer didn't like me, and that I would make cards, it would complain, and I would make changes to the cards, and it would still complain, and I'd make changes, and it would still complain. I'm like, how can I win in this situation? And you're going to feel the same thing. You're going to absolutely feel the same thing. You're going to be struggling. You're going to be like, how come this computer hates me? Let me show you right now, the computer doesn't hate you. The computer actually loves you. It just is not very good at showing how it loves you, or telling you how or why it loves you. And so syntax errors are not so much Python telling you that you're bad or that you're an inadequate programmer or you should find something else to do. It's really Python's admission that it doesn't understand what you're trying to say. And so you got to get used to that. And it's frustrating, but you got to get used to the fact that syntax errors are your friend. Python is saying, hey, I got to line 7 and I was doing fine up to line 7, but boy, line 7, there's some little thing. I don't know what the word else means in this context, or you didn't indent it, and so I'm kind of confused. What did you mean? Please, please, please help me. And so it's so much easier for you to learn Python than it is for Python to figure out what you mean when you're writing code. So we have a number of different ways to sort of encode our instructions when we talk to Python. One is we just run Python interactively on our computer. Hopefully by now you've got it installed, and you just type Python at a command prompt. So either a Windows command prompt or a Linux command prompt or a Macintosh command prompt. And I got some examples of how to sort of get this all started, get Python installed, and away you go. Now you'll notice when you run the Python interpreter, the 3 chevron prompt, Python is asking you what next, right? This is you. It's saying, I want to talk to you. I want you to tell me some Python to do. If you know the Python language, you know what to say right here. Now, if you know Python, you can type these languages. You can say, oh, x equals 1, which really means go find a little piece of memory, label it x, and stick 1 in it. Print x is like, go find that thing where you labeled it x and bring me back that number and tell me what I stored in there. Now, why you want to do this? That's a different question. These are very simple things. It's going to take you a while to get the big picture of why we're doing this. So just trust me that you want to learn these statements, and then later we will successfully turn those into a program. So x equals x plus 1, the third line there, x equals x plus 1 is not as it seems in math. It basically says, hey, go grab the old value of x, add 1 to it, and stick it back in x. That's what that means. So the equal sign really has kind of an arrow to it. And then we say, hey, go look up that x thing that we just did and print that out, and then we're going to say quit. So that's us talking to Python. Now, you can type just about any crazy stuff you want in here, and Python will be unhappy and talk to you. So what we're going to do next is we're going to start talking about the actual language of Python and what it is that we have to say to make Python happy when we're talking to it.
Wow, that was a good one. That was a quick one. I don't know about that Harry Potter reference, but hang on, let's how do I get out of here? There we go. All right. So this one actually, it has a challenge here at the below here. So what will this print out running these 2 lines? It will actually print out 6. Correct. And gosh, I hope we finish. Let me just check. I sometimes get impatient here, so just let me see how many more videos we got to go through here. One more video, and then we start chewing through on our own pace there.
So now we're going to start learning the actual Python language. So what do we say? You can think of this as almost like writing a story. We're going to start with a basic vocabulary. We're going to talk a little bit about lines or sentences, and then we're going to start talking about how to put those sentences together to make a coherent paragraph, as it were. And you just have to accept the fact that when I start teaching you this stuff, it's not going to make sense for about 6 or 7 more chapters. And so just sort of bear with me, I remember when I first learned, it went from me confused. Holy mackerel, this is awesome. And so I expect many of you will go through that same thing. So just learn the first parts, accept the fact that it doesn't necessarily make sense in a big picture, and just bear with us, okay? So we'll start with vocabulary, we'll start to make sentences, and then we'll have little short stories and paragraphs, okay? And so this is a short story about how to count the words in Python. It's got a couple of paragraphs, and we are going to look at all of this stuff eventually. So we start with a set of reserved words. And what are reserved words? Well, they're words that Python expects when you use these words that they're going to mean exactly what Python expects to mean. And what it really means is you're not allowed to use them for any other purpose than the purpose that Python wants. It's for part of the contract. It's like when you have a dog and you go, what did you think of that television program? And the dog has no idea what you're saying. And then you say, do you want to wait until Saturday to go to the veterinarian? And the dog still doesn't know what you say. And then you go like, how would you like to take a walk? And then the dog goes, walk. I know what that means. And then hits the door, right? And so the way the dog sees you is blah, 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 walk, blah, 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 food, blah, 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 treat, blah, 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 walk. That's kind of how Python looks at these reserved words. When you say class, it goes class. Oh, I know what that means. Now, if I say zap, it's like, oh, zap's something that you get to decide, or it's maybe a variable name. So reserved words are simply words that when you use these words in Python, and there's only a few of them, like and or del, or if maybe, pass maybe, in. A lot of these, you won't end up using them. It's just these are reserved for Python and part of the Python vocabulary. This is Python vocabulary. Now, when we move from words to sentences, you see that Python is a series of lines. A Python program is a series of statements. They have an order because the computer wants to know what next, what next, what next. So what next is start at the beginning. So I already talked about an assignment statement that basically says x equals 2. This is not a mathematical statement. This is a directive to say, take this variable 2, this value 2, this constant 2, and stick it in a location in your memory. And remember that I asked you to name it x. X is a variable, something you made up. You chose that. And so it's Python's job to remember it. So this says go to whatever that x is. There's a 2 in there. Now pull that x back out, add 2 to it, which makes it 4, and stick it back in x. And so that makes this a 4. So x is a 4. And print x says, go look up that thing that was an x and print it out. And so these are like, each line has something to it. I'm using a reserved word. Well, actually, that's a function, but it's a reserved word too. And so there's reserved words and all these things. And you combine these, there are operators. A plus is an operator, equals is an operator. These things do things. And we'll learn all this stuff in time. So the basic building blocks of lines of Python. Now, as we take these lines of Python and build them up, we end up making paragraphs, programming in paragraphs. And so one of the things that it's important is I showed you how to do interactive Python. So you just type Python and you type a statement and statement and statement. Those get really tiring after about 3 or 4 lines of Python because you start making mistakes and you have to start over. So the better thing to do is to, as your program gets a little larger, to write a script, put your Python instructions in a file, and then tell Python to read from the file and then run the script as it's entered in that file. We tend to name these files with .py, and I've got a series of videos that you can watch to figure out how this all works. Like I said, you can type interactively to Python, and it's a great way to experiment with Python, check to see if a statement does what you think it does, but script is the way, after we are past 1 or 2 lines of code, we write it in files and then run it separately. So there are a couple of basic patterns, and it's really important to understand each of these patterns. And like I said, we'll teach you these patterns separately, and then we'll combine them together. And when you combine them together, is when you say, oh, that's what a program is. So you have to suspend disbelief. We have a couple of different patterns. One is a sequence of steps. Do this, then do this, then do this. Conditional is like skipping something. Repeated does it over and over and over again. Computers are really good at repeating stuff, much better than people. People get tired going over and over doing the same thing. And then we have store and repeated steps as well. And so if we take a look at this, and we take a look at a Python program, this is a piece of code. This is a little script. If you type this into the code, take this code, Python code, into a file and ran it, it starts at the beginning, and it goes to the next line, and the next line, and the next line. And Python executes the scripts as you write them. So it says stick a variable to find place called in your memory called x, stick 2 into that. Okay, then go to the next one, print that out. So the program's producing output. Now go read x and add 2 to it and stick it back in x, so x is 4, then print that. This side over here is called a flowchart. I'm not going to make you draw flowcharts. I'm only going to draw them a few times in ways that I think will help you. But you can think of it as Python, when it finishes something, it goes on to the next one, unless you tell it otherwise. Finishes this, goes on to the next one. Finishes this, goes on to the next one. Finishes this, and now the program is all done. And so that's sequential steps. You just type them in, Python runs it. They're important, but sort of uninteresting because you can only get so far, and you can't really make them intelligent because it's always going to do the next one. So the next thing we do is what are called conditional steps. And this is where it starts getting intelligent. I mean, where you are able to encode your brain into the computer. Like, oh, wait a sec, let's only do this step if something is true. And the syntax that we tend to use here is the reserved word if. Okay? And so the if is like a little fork in the road. You can go one way or you can go another way, and you're asking the question. So inside the if statement right here, there is a question saying, is x less than 10? That resolves to a true or false. If it's less than 10, that's true. If it's greater than 10, it's false. And so then what we do is, if it's less than 10, we have this indented block of code. There's also this colon that tells us we're in the beginning of an indented block of code. And so what it basically says is, if this is true, run that code. If it's false, skip that code. So it can either run it or skip it, depending on this question that's being asked. Now, if you look at this code, it's pretty obvious what's going on. It comes down, x is 5. If x is less than 10, that's true. So it runs this code and prints out smaller. And then it comes back here, de-indents, the next basic sequential. This ends up being kind of a block. If x is greater than 20, if x is greater than 20, oh, come back. If x is greater than 20, this turns out to be false because x is 5, and so it skips this. So the bigger never comes out, and then it continues on and prints fini.
Okay. So let me just see here. He's going really quick here and some code here. So the flowchart is actually kind of helpful on this part here. So x equals 5. Is x less than 10? Yes. Print smaller. Is x greater than 20? No. Print fini or print bigger. I see. Okay, so yeah, it'll just print one of these statements. It won't print both of these statements, and then it prints fini. Okay. Just wanted to walk through it just to make sure I didn't miss anything.
Oops, that's a typographical error. Make that a lowercase print, and it prints fini. So it comes in, runs this, skips this, and then finishes. Okay. So here is the last one we'll talk about, the repeated steps. We'll get back to store and retrieve later, but for now we're just going to talk about 3 of the 4. This is another program, and the key is that we're going to use the same choice where we're going to go in, but then we're going to run for a while, and then we'll have an exit condition where we get out. So this is a repeated over and over and over and over again, and this is the essence of how we make computers do things that are seemingly difficult, while they're more naturally difficult for people. Okay, and so how do we encode this notion that we want to do something not forever, but
okay? So he's going to walk through another chunk of code here. This is just called a loop. So, I mean, I'll let him go in his chipmunk voice here. And we'll be actually going through some examples, so don't sweat this. But basically what he's basically just gonna loop this around. So it's, oh, sorry, I keep closing the chat. It's nice to be able to go through this with somebody who knows and can walk me through it. Yeah, no worries, man. So yeah, so the first one, we assign n a value of 5. And then this statement here is what loops everything. So it says while n is greater than, what's this say? While n is greater than 0, print n. So 5 is going to be greater than 0, so it's going to print out n, which is 5. And then the next line is what the fancy word is called decrement. So if you're adding anything, it's called incrementing. If you're taking anything, it's decrementing or decrementing. I think I'm pronouncing that right. So this line will do n equals n take away 1. So then it'll loop back up to here. Because of this indentation, it's just going to do these 2 lines over and over. It's going to do a check, and then it's going to print, and then it's going to take away 1, and then it's going to check, and then it's going to print, and then it's going to do 1. So basically his output is 5, 4, 3, 2, 1. And then when it gets up to, like, once it gets past this n take away 1, so after it prints 1 and it goes to check again, it's going to say is n greater than 0, and because n is going to be 0, it's going to say nope. And so then it finally goes to the next line, which is blast off. I wonder if he's going to say this here, but there are some cases where you can get what's called an infinite loop. There's usually things set in to prevent a computer from going crazy. But when I first started coding, we would always try to make an infinite loop just for fun. So we'd say something like, as long as n is greater than 0, and then instead of taking away 1, we just kept adding 1, which means this will never not be true. You'll just have an infinite number of scrolling until you either kill the computer, win that, lock up the computer. Yeah, exactly. That's what we would do. We would run a program and we'd like, we'd laugh because the screen would fill up with numbers, but then it would get to a point where it's like, oh shoot, now what? And the answer back then was, well, we'd have to recycle the computer. We'd have to shut it off, turn it back on. Now, there's ways to just kill the program, or sometimes they have like guardrails built in that says, okay, you have an infinite loop. Things are out of control. We're going to kill the program on your behalf. But yeah, you got to be careful with loops. But this is an example of him showing us how to do a loop and walking through it.
For a while, how do we encode that notion? And so we do it in this way. So we have our statement, sequentially go to this while. While is a keyword, and it's asking another question. That's a true-false question. Is n greater than 0? I read this as long as n remains greater than 0, keep doing this indented block. And you have a colon at the end, and then you have 2 lines of code that's indented. So that tells us what the loop is, and then this is now de-indented. And so it comes in, and if this is true, it runs these 2 lines. Prints out n is 5, and then it says n equals n minus 1, which makes n be 4. It goes back up, and it goes up and asks this question again. Is n greater than 0? If it is, continue on, and prints 4, and then subtracts it, and it does that. 4, 3, 2, and prints out 1. Then it comes up, and now after this, n is now 0, n is now 0, and n is no longer greater than 0, so it takes sort of the exit ramp and goes down here. So it takes the exit ramp and goes to here and runs the next line. Now, we're going to cover all this again. So I'm just trying to give you the big picture. Next couple chapters, we're going to hit all these things again, and we're going to hit them in much more detail with a lot better information. This is now sort of like combining these. And again, I don't want you to really like know this stuff. You will know this in a couple of weeks. You will see this program again. But this shows you how we combine those patterns of repeated, sequential, and conditional together. So this is a bit of sequential code. Comes in here, runs this, which happens to ask for a file name. Then it opens the file. It creates a data structure called a dictionary. This is all sequential. Now the 4 is another form of loops. So this is going to loop for a while. And then this is within a loop. We can even have 2 indents, and that's another loop. So these are like repeated. And then it goes down to the next sequential bit. Then it does this. Here's another loop. It's going to run, and then here's a conditional. It's going to run. And then once all done, we print out the last thing. And this is of course.
So I'm just going to give my 2 cents on this. It's great to know the jargon. It's great to know like what is what, but that's like somebody trying to teach somebody English. Like when you are I don't know how to say this, but basically you don't stop and think, am I using a pronoun or am I using an adverb here? Right? You just get to a point where you're speaking the language naturally, right? I don't sweat trying to learn like, oh, is that a sequential state? Like that means nothing to me. What he's basically saying is sequential. It means it's going to run and then it goes to the next one. Okay. That's true for every one of these lines. So I don't know. Repeated. That's a fancy way of saying a loop. And conditional is basically like if statements. So, this is a lot of academia jargon attached to some of these things. So I never sweat trying to memorize, as long as I have the concept and can translate it to another language. This example here, like this, what I was noticing was interesting is this colon here, right? That's unique to Python, right? So I didn't know that off by heart, but I know what a for loop is, and I know what a loop is, right? Now, if somebody introduced a new computer language, like, whatever, Go is made by Google. It's kind of like the C++, but I guess for web. They will have loops similar to troubleshooting. You might not know what the name is, but you know exactly. So we wouldn't know what the for loop looks like in the Go language, or we wouldn't know what how they declare variable values. It might look the exact same, or they might have some kind of little wacky particulars. And that's I can show you an example before we wrap up. What I'm trying to learn, I'm trying to just for fun learn on the side, and most of it is just trying to figure out, okay, what does that mean? But I have the concept. I get what's going on here. So yeah, just don't sweat all these.
Is the program that does it figures out the most common word and prints that most common word out. And so this is a Python short story. It reads some data. It reads the name of a file, opens that file. It talks about how to make a histogram, and then it looks through for the most common word. So don't worry too much about this. Over the next couple weeks, we'll fill in the pieces so that you absolutely understand every single line of this code. So this is a quick overview of Chapter 1. Stick with us. You realize it will be Chapter 7 before this makes too much sense. You really have to trust that you are learning important things and that it all makes sense when we bring it together like in Chapter 7 in a few weeks.
Bling. So this is a nice little way for him to sell his book, it looks like. I assume that's him teaching this, or maybe he's just using the book. To answer your question, Sean, what language do you recommend starting out with? You know what? If you've been to a few meetings and you've mentioned Python a few times, I'd start with Python. They actually they teach in college and university when they're teaching languages for the first time. They're now using Python almost exclusively. And the reason is because it's a great language to learn and sink your teeth in right away. Some of the, I'll say the older school languages like assembler, C, C++, there's a lot of initial groundwork to just understand how the hell it works before you can do your hello world program. Python, you're basically, oh yeah, Georgian would definitely have a night course. 100% they'd have a night course. If not, they should be scheduling one soon. Yeah. And it's, a great book I got at the Barrie Library, if you're interested in it. Because I was interested in maybe one day becoming a data scientist. I was entertaining that once upon a time. Never did pull the trigger. Where is it? This one here, this book, you can, yeah, please, never too late. This one here, data wrangling with Python. It was really fun because they basically walk you. Well, you're only 7 years older than me, so you don't have too much of a head start on. But yeah, I found this. It was a fun book from the library. I think there's a few free copies floating online if you want to try to pirate it, but definitely check out. They have a ton of Python books at the Barrie Library if you want to check out Python. And this one was fun. There's another great book that I always point people to. It actually just popped up there. This one here, the guy actually put his whole book for free online. And I actually bought the ebook because I love this book so much. This guy basically walks you through test-driven development with Python. And once you get a little bit of Python under your belt, or just get a bit of web development under your belt, I highly recommend you check out this book. It was mind-boggling for me, really, because his whole approach, and this is getting off topic, but it's test-driven development is you write little tests to code something out. And so that's actually what I'm trying to work out on the side for another project is I'll write a little test and then try to write some code to make the test pass. Then you write a little bit more code and then try to, and it's an interesting way of developing. It's popular in some places, not so much, but the long and short of it is it's all with Python and other tools. And it's actually pretty incredible what you can do with Python. So definitely check it out. All right, let's get into this challenge here. I don't know how late you want to talk, Sean, until you tap out or until I tap out. We'll just keep going. Okay. So what will the following program print out? If X equals 43, and here we go. So the answer is going to be 44. I'm good to go all weekend. I wish I was going to go all weekend. We'll go for a few hours anyways. Maybe 1 or 2 hours. We'll see. All right, here we go. Let's go to the next challenge here. I thought we were done. I thought we were done with the videos. What's going on here? There's probably going to be a video for every subject, are we? Gosh. All right.
Hello, and welcome to Chapter 2. Now we're going to continue to talk about the building blocks of Python, variables, constants, statements, expressions, etc. The first thing we have to talk about is constants. These are just things we call constants because they don't change. They're numbers, strings, etc. And we use them to sort of start calculations, or if something is greater than 40 hours, we're going to do something. So 40 is the constant in that situation. So we have 123, we have 98.6, we have hello world, which is a string by enclosing in quotes. We pass each of these things to the print function, and a side effect of the print function is that we see the output. So print 123, prints out 123, print 98.6, prints it out. So these are just really the syntax of constants, and without constants, we can't write really much of anything. The other sort of foundational notion of any programming language are the reserved words. And like I said before, reserved words are these special words where Python is listening for them, and there are very special meanings. So when Python sees if, it's not just any other word, it means how Python implements conditional execution. Variables are the third building block, and that is a way that you can ask Python to allocate a piece of memory and then give it a name. And you can put stuff in that. Sometimes you just put one value. Later we'll see, we do collections in chapters 8 and 9, we will see the more than one value can be put into a variable. And the variable, how we control the variable is through the assignment statement. And as I said before, it's important to think of the assignment statement as having an arrow to it. So this is not saying x for all time is the same as 12.2. What it's saying is take 12.2, find a place, find some memory in your computer there, Mr. Python, give it a label x, we get to choose the x, that's the variable part, we chose it, right? And then stick 12 in it. And then the same is true for 14. Go find another spot, name it y, and then put 14 in there. So think of this as an arrow every time you see that equality, the assignment in an assignment statement.
Now, variables, I wish when when I try to explain algebra to young people for the first time, or just trying to share algebra, if I hear people say, I struggled with algebra in school, this is where I wish somebody had shown me this, because if you got a good understanding of algebra, you basically can code just about anything. A variable is basically a placeholder to put a value. So technically, I wish they showed me this in algebra class rather than what the teacher did do, which was mix up letters and numbers on the board and said, okay, we're learning algebra. And I was like, what the hell are you talking about? But the idea of a variable being almost like a container or something to hold a value, that was a game changer for me back in the day.
Now, these variables hold one value. So now if we have these three statements, these two, and then the third one executes, it says put 100 into x, but that wipes out the old value of 12.2 and rewrites it with 100. And so we can change the variables. That's another reason that we call them variable. There are some names, now there are some rules for making variable names. You can start with a letter or an underscore. We tend not to, as normal programmers use underscore, we tend to reserve those for variables that we use to communicate with Python itself. So when we're making up a variable, we tend not to use underscores as the first character. You can have letters and numbers and underscores after the first character, and they're case sensitive, but it's really a bad idea to use case as the only differentiator. So in this case, spam egg, spam 23, and underscore speed are all totally legit. We would probably not use this one unless we were actually doing it because Python told us to use that variable. 23 spam starts with a number, pound sign starts, and dot is not a legitimate variable character. And spam, capital spam, and all cap spam are different, but this is not something that you want to sort of depend on too much. So that's just the rule names. We tend to start them with a letter and then use letters, numbers, and underscores. Underscores other than the first character are generally pretty common, and you'll see those used a lot. Now, when we're choosing variable names, one of the things about variables is we get to choose the name. We get to choose the name X, choose the name Y. And so sometimes we like them short, but sometimes we want them descriptive. And the notion of making variables descriptive is often confusing to beginning students. Sometimes it's really helpful to, if you're going to have a line of text and you name the variable line, that's great because the next person reading your program says, oh, that must be the line of text. Whereas it also can become misleading that the name of a variable somehow has meaning. So sometimes we're writing singular variables and plural variables like friend and friends. And you're like, is plural? Does Python know about singular and plural? And the answer is no. So sometimes we pick variables that make no sense. Sometimes we pick variables that make a lot of sense. This is just something that you as a beginning programmer are going to have to understand, that we can pick anything we want. And so you'll see, I'll try to call attention to this in the first few lectures as we go through. So here's a bit of code with an assignment statement, two assignment statements, a multiplication, and a print statement. And you can say, what is this doing? Now, Python is perfectly happy with this code because it assigns it in there. You have said, please go give me this as a label. And then we assign two variables. And then we're carefully pulling these two variables back out, multiplying them together and sticking them into yet another variable, and then printing that variable out. That seems like, we can figure out what it is. You just have to look really carefully. And a single character mistake, and Python is going to be, pretty unhappy. Okay. So that's one way to write this program. It's hard though, because any of those characters are long variables and they're random stuff. it's not very friendly to anyone who might read your program. Now this looks a little friendlier. It's the same program because Python just wants a correspondence. You pick A, you pick B, and you pick C, and it's really much easier for us to see what's going on. And so this is, in a way, going from here to here is much friendlier, but we can be even friendlier if we pick mnemonic variable names. So this is not mnemonic, this is short and convenient, this is long and inconvenient. Python is happy with any of these. Here, on the other hand, is another version of the exact same program.
Yeah. So yeah, I hope this is clear. Like he's just using different variable names. Well, actually, what I thought he was showing here in this, the yellow was now it is. Yeah. There's a horrible way to explain things. I think he was basically just saying, like, look at this confusing example, and now here it's clear, and now here it's clear. But yeah.
And now you think to yourself, oh yeah, now I get it. 35 is the number of hours, $12.50 is the rate, and then we're going to multiply the hours and the rate and come up with the pay, and we're putting out the pay. Now whoever wrote this program is helping us greatly understand what's going on, and that's good. Choosing variable names. Python, again, all three of these are the same to Python. Choosing variable names in a way that help your reader understand what's going on is a great thing. The problem is, the danger is, if you read this and you think that somehow Python understands payroll, that if you name a variable hours, that Python knows what hours means, the answer is Python really doesn't care what you name the variable as long as what you name it, you use it, right? And so you got to be careful. And so you'll see, when I write my code in these first few weeks, first few lectures, I will sometimes write it with gibberish. I'll sometimes write it with extremely short but meaningless variable names, and sometimes I'll use meaningful variable names, and I'll call your attention to it, and it will get you. You'll start, when you look at this third kind, it has meaningful variables or mnemonic variable names, you'll just instinctively want to give Python more intelligence than it sort of deserves. I guess that's probably the best way to say that. So we talked about constants, we talked about reserved words, we talked about variables. And so here we have a sentence, like we've already done some of these things where we set x equals 2, we retrieve the old value of x and add 2 to it, so that becomes 4, and then we print 4 out. Print is a function that's built in, and we pass in whatever we want to print out. So this parentheses is part of a function call. Okay, so an assignment statement, you have to really get your head around the notion that it has this arrow nature, and that it evaluates this entire right-hand side before we change the left-hand side. And so you can think of this sort of as at time step 1, it does this, and then at time step 2, it does the copy. And that's how you can have something like x on both sides of an assignment statement. And so if, for example, we have x, and x has 0.6 in it, what happens is that it sort of ignores this part right here and evaluates the expression. So it pulls the 0.6, everywhere x appears, it pulls 0.6 out, then it starts running these calculations, and then it has the new value. After all the calculations are done, then and only then is it going to put that back into x. And so it sort of takes that and puts it back into x, and then wipes out the old value. At this point, this has all been taken care of, and it's been reduced down to the 0.93, and so that...
I don't know why he's going to great lengths to try to confuse people. I mean, I guess he's doing a good job. He's thoroughly going through this, but basically stuff happens and then the value is now changed for the variable. That's what I'm getting from this. It's a little overboard. I mean, I don't know if he's giving us football plays here, and it doesn't help that I have it in chipmunk speed, but
that is what's put in as the new value. So up next, we'll talk a little bit more about making more complex expressions.
All right. Possibly passionate. Yes. He's good. Actually, he's a good teacher. Okay. What is a symbol used to assign things? That's actually easy. Equal sign. Ding, ding, ding. All right. Next one. There's going to be a video for each one. That's crazy. Okay. Are you okay if we try to do it without watching the videos? Only because they're going to be like 9 minutes a piece, and I don't. Yep. All right. Good. We'll use it as a resource if we get stuck. But the question here is, what will print out after running this code? And this is intermediate expressions. So if width was 15, height was 12, and we're going to divide. The answer is going to be 4. Because we're taking 12 divided by 3, and that should be 4. Sorry, that's not right. Oh, look at that. Bang. I guess I was wrong. Integers. It's a float. Yep, thank you. You're right. That's interesting. Yeah, I'm sure they got into it there. Bang. Okay. Good call. Next one. Conditional execution. Which code is indented correctly to print yes if x equals 0 or y equals 10? And I would almost say it's the last one. So if 0 equals x, indent it. and then do another if statement. If y equals 10, print yes. I think it's this one. Yeah. Oh, yeah. B. Oops. More conditional structures. Okay. Given the following code, temperature is a string. Celsius is a number. Fahrenheit is a float of temperature, which doesn't make any sense in my opinion, because that's a string. So now we're interesting. And then Celsius is Fahrenheit, take away 32, print cell. Which lines should be surrounded by the try block? I'm going to go ahead and say none. A try block is usually, now maybe I'm wrong. I don't think I'm wrong, but we'll see. A try block is usually, is that a while loop to use? Try? No, a try block, and maybe he gets into here. Actually, it's worth watching this. We'll check it out.
So welcome back. Let's talk a little bit more about some more complex conditional statements that sort of build on this concept of if and if then else. The first thing we're going to look at is the multi-way branch. And so the idea is it's kind of like the if then else, where you're going to pick one of two, but now we can pick one of three or one of four or one of five. And it introduces a new concept called the elif. The elif is another reserved word inside Python. And the way it works is it's probably best to look at this here, where it checks the first one, and if it's a true, then it runs that, and then it's done. It doesn't check them all. It's not like it sees that there are two logical conditions. It actually checks them, the first one, and how you order these matters, as we'll see in a bit. And so if the first one is true, it runs. If the first one is false and the second one is true, it runs this one and it's done. And if the neither of them are true, it falls through and there's an else clause that is otherwise, and it runs that. So basically, it's either going to run one and then skip the other two, or it is going to skip one, skip two, and then run this one. But it only runs in this case one of them. But the important thing is it checks these questions in order, and it doesn't check the second question until it finds that the first. It doesn't check the second question until it knows the first question is false. So if the first question is true, you're done. You're done, and you're done with this. You're done with the whole block at that point. So only one of these three is going to execute in that block. So here's sort of some examples of this. If we, for example, have x equals 0, it's going to come down here. X is less than true. That's true. So it runs this code, and then it skips down to that. And so it's like this, runs that code, and then skips to the end. Okay. On the other hand, if it's 5, then this is false, and it skips that, and it checks this. This is true. It runs this code, and then it's done, skips to the end. It was like false, true, run, end. And then if x is like 20, for example, it runs, false, false, run the else clause, and you're done. So skip, oh, else, run that code, and you're done. So in this case, we ran that, and we didn't run that, and we didn't run that. Again, one of them's going to run. They're checked in order. These questions are checked in order, not out of order. It doesn't look ahead. It just checks in the order that you wrote it. You're the one that wrote that order. And so there's a couple of variations on this multi-way. You can have no else. You can have no else, as in this case. And this just means that it might not run any of them. In this case, x is 5, so it's not less than 2, but then it runs this one. But if x was like 50, for example, if x was 50, then this would be false, then it would skip, and this would still be false, and it would skip, and neither of these two would run. So if you don't have an else, you're not guaranteed that one of them is going to run, because else is like a catch-all. If the other ones are all false, then the else is the one that runs. Similarly, you can have many elifs, but this is where it's really important for you to make sure you know what order they're being taken in. So I've got, this, if this is true, it runs, it goes all the way to the bottom. If, this was, if it's false, 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 true, it runs this one and it's done. If, on the other hand, it looks at it as false, oops, go back. If it runs false, 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 they're all false, then it runs the else. Right? This one has an else, this one didn't have an else. They don't have to have them. The key is you can have more than one of these elifs. Okay? So I got a couple little things. I'll let you pause right now and look at, the question is, are there, looking at the 3 lines or 4 lines of code, x equals something. Are there lines of code that will never execute regardless of the value for x? And I'll let you pause and think about
it. Which will never print regardless of the value of x. If x is less than 2, print this. Else if x is greater than or equal to 2, print 2 or more. Else print something else. This one, if x is less than 2, print below 2. Else if. So this is not in order. So all this is bunk, I think. I think that's what he's going to point to, because you're kind of funneling down, and so there's no way these are ever going to execute these lines. I think that's the answer.
And then I'll explain it to you. Okay, hopefully you paused and thought about it as long as you like, but so let me now explain it to you. So we come in here, and if x is less than or equal to 2, it's going to run this first thing, and if x is greater than or equal to 2, it's going to run this, and if neither of those are true, then it's going to run this. Well, the weird thing is, all numbers are either less than 2 or greater than or equal to 2. I carefully constructed this to the point where it would never run this line of code. It is either going to run...
I missed that one. If x is less than 2, print this. Else if... Wait, hang on. Yeah. Oh, I see what he's saying. Because this is kind of a binary. Is it less than 2 or is it greater than equal to? Those are the only two conditions you can have. Less than 2 or equal and greater than 2. There's no third option to that question, right?
Run this one or run that one, but it's not going to ever run this one. Sounds kind of like a weird dysfunctional one that I constructed. This other one is a little different. If x is less than 2, we do this. If x is less than 20, we do that. If x is less than 10, we do that. And if none of those are true, we do that. Well, the problem here is between these two lines. The problem is if something's less than 10, like 6, for example, it's also less than 20. So even though there might be values for which this is true, those also are going to have this true. So for something like 6, it's going to run here, and it's not even going to look at this. That's the point. It doesn't even look.
Okay, hang on. If x is 6, yeah, I still think, if it was 6, it would never run into this. If it's less than 2, print that. Else, it's less than 20, print that. Is it less than 10, print this. I'm confused what he just said there. Hang on.
Are true, we do that. Well, the problem here is between these two lines. The problem is if something's less than 10, like 6, for example, it's also less than 20. So even though there might be values for which this is true, those also are going to have this true. So for something like 6, it's going to run here, and it's not even going to look at this. That's the point. It doesn't even look at this. And so that's, I mean, I could have made this more sensible.
I see what he's saying. So if it's 6, it's going to execute right there, even before it gets to this check. Does that make sense? It's going to say below 20. As soon as it hits that one, it's going to below 20 and boop, it's going to print that. It's not even going to get to 10. I see what he was saying there.
Move this little block of code up to there. So this is where the order in which you choose your questions, the way you put these elements together matters because it doesn't look at all of them. It only looks as long as it can. As long as it sees falses, then it keeps on going to the next one. But as soon as it doesn't see a false, it doesn't continue. So the last conditional structure we'll talk about is the try and except structure. If you know any other languages like C++ or Java or JavaScript, you're like, well, that's kind of an advanced concept. But it turns out in Python, because of Python's propensity to throw tracebacks, in situations where you kind of would like to recover it, it turns out you kind of have to use it a little more and a little earlier in your programming skill. So the problem is what if there is a line of code and you absolutely know it's going to make a traceback, it's going to blow up, but you don't want to blow up. I mean, I don't want to have code blow up. If you're using my autograder and you see a traceback in my autograder, that's kind of like I consider that a failure. I could put an error like, hey, you entered blank data or you didn't enter a number, but a traceback, that just seems like I'm too lazy as a programmer. So we as programmers are supposed to anticipate parts of our code that are going to blow up potentially based on perhaps the user's input and then do something about it. And that's what the try and accept are for. If you take this little dangerous piece of code that might break and might blow up and you surround it with a try and says this might blow up and if it fails, run this code down here. Okay, so that's the try, and if you get an exception, the accept is kind of like if you get an exception. And the problem is if you are running code, here's a little bit of code. We put hello Bob in and we convert it to an integer, and we know from past experience that this blows up. Right? You can't take hello Bob and convert it to an integer; it's just going to blow up. The problem is here we are. It says, oh, you blew up on line 2. That's great, and I'm not very happy with hello Bob and whatever. But the important thing is your program stops. These other lines, they don't. Oops, these other lines, they don't exist. Right? It doesn't go any further. Remember, the traceback is Python is really confused, and I don't know what to do next. So Python is just going to be conservative and stop. So Python stops, and your program stops. No matter how much error checking you put down here, it doesn't matter because it's gone. It's all gone. And like I said, we take this kind of personally because the code that you write is like you being put into the computer, giving it instructions. And if the code blows up, well, that sort of wipes you out. You're not in the game anymore. You're not able to do anything. So we want to be able to, especially in these situations where we can anticipate that an error that might happen in the normal course of your program's execution might be something that you want to compensate for. And that's what the try and accept does. So here's a bit of code for the try and accept. And we just have two little bits of straight line code. And so we put a string in here that's hello Bob, and then we're going to convert it to an integer. This is the dangerous code. This code in this case with hello Bob.
So yeah, that example, because I was confused, like, oh, you can't change they went from a string and then try to change it into an integer, or they tried to change a string into a float. Remember how I said something like Fahrenheit, and then so that example we're going to see is exactly this. And I was going to say this before we watched the video, but yeah, usually I've seen try around error handling. So he mentioned how it's a little bit lazy because what's going to happen here is the Python is just going to throw its internal error message where he's saying you could set it up in advance. So this is it's like a poor example of error handling. He's kind of, they're presenting it almost on purpose. Like, how can we break something on purpose so you can learn about error handling, right? There's a new language. I think it's Microsoft has built. It's called Typescript. Are all programming languages able to do the same thing? It's just in a different, ruder way. Yes. So I was just about to say this. So there's this new language called Typescript, and the whole reason why TypeScript has become so popular is because they don't allow any of this nonsense. This is the danger with Python, is that this can happen. If he didn't wrap this up in a try, you can get away with this. You can make something a string, and then you can turn it into a number. Then you can take that number and then turn it into a bin file or something. That's called a dynamic language, which means you can dynamically like whatever you want. It's called Typescript. TypeScript is the language. So this is called case. Yeah. I don't know if that's what you were trying to refer to. Not case. Is that types? Yeah, sorry. TypeScript is for types. So yeah, when you say like this first one here, when it says hello Bob, you've basically said the type is string, right? And the next one is an integer. Some languages, they're very strict. Casting a variable into a string or an integer. Yeah, what they're doing here is that they're putting a string into a variable and then they're mutating it. That's the other fancy word they're using a lot, is mutating the data. I mean, this is a whole other discussion about some of these newer programs, but a lot of people think that you shouldn't mutate the data. And Facebook has become kind of popular with their whole React framework, is that they kind of introduced this idea of like true functional programming, is that you should never be able to take a number and then, I want to turn it into a string or a word. It's like, no, that's a number. And if you want to do anything with that number, you're going to have to take a copy of that number and then try something else, like fake news. Exactly. Yeah, they have a whole other issues on content, not the technology. But I mean, we could argue till the, cows come home. But yeah, basically, yeah, it's a good example. Like, it's an example of error handling, this try and accept. But where you'll see this come into actual real programs, not like these little tutorial examples, is that when you try to call something, so when you try to call another website or you try to call another API service, there's a possibility it will fail. Like the networks might be down, the websites change. So you want to wrap that around some kind of error handling, or that's what I've seen in examples, is because you're not sure if you can connect. And so you want to be able to anticipate that. That's the only scenario I can think off the top of my head. I'm sure there's plenty of other scenarios where you think, this calculation might not happen because I might not have the information available. So let's wrap it around in a error handling. That user data.
Traceback. And so we say try, and then we indent the dangerous code, and then we add this little accept bit. If it works, the accept is ignored. If this blows up, it runs the accept. So in this code, it's going to come in, it's going to try this. This is going to blow up. But instead of giving a traceback, it's going to say, I've got an available accept. I'm going to run this accept code, and then I'm going to continue on. And so that prints out first -1. So because we set this variable Eister to -1, like a little flag telling us that something went wrong. And then we keep on going, and now we have put in 1, 2, 3, the digits 1, 23, the digits 1, 2, 3, and now it's going to work, but we still have it in a try block, and then this one works. It does not blow up, and then ignores the accept block. So the accept block is only triggered when something goes wrong in the code. It is ignored if something doesn't go wrong. So it's like you bought an insurance policy on this line of code, and when things go wrong, your accept block springs into action and does whatever it is that you want it to do in the case of an error. Okay, so that's a pretty useful thing. You got to be a little bit careful that you don't overuse it, because if you put more than one line inside the try part and one of the lines blows up, it doesn't come back to the try block. And so in this one here, we have kind of a simple, silly one where we set the string. We're worried about some stuff with the print statement's never going to blow up, so it's a bad idea to put it in try except anyways. Then we do this conversion, and that's the dangerous part. And in this one, it's going to blow up. And so then it's going to go to the accept block and then run the accept block and then continue. What it doesn't do is somehow go back and finish this. So these lines are gone. So if you look at it like this works. The try starts, hello, this blows up, it goes to the accept, it runs the accept, and it continues on. Never runs that code. So it's not like you took out an insurance on the whole block. Any of those lines can blow up in the block, but whichever line blows up, that is the last line that's executing in that block. Okay? So you tend to want, in this particular example, you would probably, the print statement would go up there, and this print statement would come down here, and you'd only put in your try block the single line of code that you think might blow up, because you kind of know print statements aren't going to blow up. So this is an example that's a more common real-world example, where the user is going to type some data. And it's users that get us in trouble. So our program starts by asking the user to enter a number, and we know that this could be dangerous. So we're going to do it. We're going to put the conversion from string to integer in a try block, and we're going to set -1 if that's a failure. And then if it's greater than 0, we'll say nice work, and if it's less than 0, we'll not a number. So first time we run this program, out comes enter a number. We type in 42, which is a string. That 42 goes back into roster, runs in here. This runs. It's fine. That becomes a 42 number. So we skip the accept block, and I value is greater than 0. We print out nice work, and we skip the else. Okay. So it says nice work. On the other hand, if we run it again, this time, the input says enter a number, and we're silly, we enter the word 42 but in words, 40, F-O-U-R-T-Y. So that's a string that goes into roster, and then the execution continues. We run in here, and now this is going to blow up. That's going to blow up. Normally, we would see a traceback right there. There'd be a traceback. But we're not going to because we put this calculation in a try and except block. It's going to immediately run the except block, set I value -1, continue on with the program. So you are not blown up at this point. And if I value is greater than 0, well, it's -1, so we're going to hit the else clause and print out not a number. So we've done error detection. The user set something that caused a line of our code to kind of blow up, but we put that line in the try and except block, and so we caught it. And so we dealt with that fact. So in summary, in this, we talked about if statements, we talked about else, we talked about try and except, how important indentation is to mark blocks where they begin and the end, and an else if and try except. So up next, we're going to talk about loops and iteration.
All right. So I'm glad we actually did watch that video. So I want to keep a perfect score here. So the answer is going to be 3, I think, or it could be 3 or 4 here. So let's see here. Which line should be surrounded by a try block? I think it should be 3. We'll see. See you in a second here. Let us check. Nope. So it's 3 and 4. Boom. Okay. All right. Oh, I'm about to sneeze. Sorry. All right. So just a little after 8. And we're chewing through it pretty good here. Okay, so what is the purpose of the def keyword in Python? It is slang that means the following code is really cool. It indicates the start of a function. I think that's the real answer. It indicates that the following indented section of the code is to be stored for later. It indicates that the start of a function and the following of indented section of code is to be stored for later. I think it's this one. Function or method. Yep. We're on the same page here. Nope. Huh. Maybe it's this one. Yeah. Okay, that's interesting. I guess save for later indicates that you save it in memory. Like it sees a function, it sees the indentation, it saves that. Right? Yeah. That's what I'm thinking. Oh, yeah. Have to click on that button. Okay, build your own functions. Okay, what will the following Python program print out? So we have Fred that prints out Zap. We have Jane that prints out ABC. So we have Jane, Fred, Jane. So it's going to say ABC, Zap, ABC. There it is right there. Bang. All right, on to the next one. Loops and iterations. Ugh, I don't want to go through that again. We can just go through loops here. So what will the following code print out? So n equals 0. So while true, interesting. So this will just keep looping until it hits break. So if n equals 3, leave the loop. And then print out n. So this is now going to iterate. So it's actually going to say, this is going to say 1, 2, and then that's it, 0, 1, 2. Is it? Because we start on 0, so it's going to start 0, 1, 2, and then by the time it gets to 3, then it's going to exit the loop. Yep, too easy. All right. This looks like he's really going for it with that football pen. A definite loop with strings. Interesting. How many lines will the following code print? For I in 215, I mean an index. Yeah, they could have made this anything, but yeah, that's exactly normally what it means is index. So this looks like an array. So yeah, this looks like he's going to talk about loops with arrays. So, I mean, we don't even have to watch this video. I can tell you exactly what this chunk of code basically says. So he made an array called friends, and it has Joseph, Glenn, Sally. And then it says for friend and friends. So he's basically saying singular in the plural. So this is kind of unique to Python itself. Print Happy New Year friend, and then go through it. So this is exactly what's going to happen. It's going to go through 215. And so how many lines will the following code print? It'll print 3 lines is the answer. Yeah. It's kind of an easy one. This one is, what's this? Loop idioms. Ooh, really spent a lot of time on loops. The below the code is to find the smallest value from a list of values. One line has an error that will cause the code not to work as expected. Which line is it? All right, so the smallest equals none. Print before and smallest. So say before none. And then it'll say for iter var in 341, 12, 9, 74, 15. Okay. So if smallest is none, or this, it looks like an error right here. I don't think they used the word or. I could be wrong. If smallest, this should actually, and this should be, I don't know, this looks odd to me. I would say line 4. If I was going to write this in code for most languages, I would put if smallest double equal signs none, and then I'd use the pipe up and down character for or. Or if this is less than smallest, smallest equals that value, then break. Yeah, this is an odd wacky code here. So what it's trying to do is trying to go through, just like I said, it's trying to go through the array and trying to find the smallest value. So it's trying to find 3 is the smallest value out of all of these. Yeah. So this is going to break at line 4, I think. You're saying line 7? Line 7. Which line is it? Will cause the code not to work as expected. Loop, print loop, value smallest. You might be right. What I think line 7 would do is just print loop, and then it would print whatever values in the at the time. Actually, no, you're right. It's after the break. Wait, hang on. Yeah, what's happening here? Line 6. The fact that you just said break, that's interesting. So it's going to go through here. So maybe this is valid. I thought it was number 4 because I've never run into this, but maybe that's unique to Python. Indent, not tab. Oh, did I say tab? Sorry. Indented. So I thought it was going to be line 4 because of this, but maybe that is perfectly okay in Python. So it's going to say this is correct. It's going to assign. So if the statement is valid, then this line is correct, but this is just break. So it's going to break out of the loop. And yeah, I think it's 6. 6. Yeah, because you don't want to just randomly break out of the loop. Normally you would only break out of a loop as if you met your conditions. And in this case, it hasn't gone through the entire array yet. So it's going to get to number 3, the first value in the array, and then it's going to leave the loop before checking the other values. So that was the problem with that program. All right, iterations. Which of these evaluates to false? We might actually have to watch this video here. So which of these values equals to false? So 0 does equal 0. I think 0 is 0. I like the way you make it easier to understand. Yeah, man, absolutely. I think it's this one. Let's go. Let's see how this video is.
So now we're going to look at some more patterns.
Yikes. 18 minutes. As much as I like to go through this. You can watch this on your own time. So all these conditions are 0 except this one. 0 is 0. It's not 0. So that, something is wrong here. Maybe it's this one. That's assigning 0 equals 0. No. 0 equals 0. So this is an integer and that's a float. Maybe that's it. Oh, 4 is a variable. 4 is a variable. So it's not that one. It's not that one. It has to be this one. What? 0 is, man. That's, I don't know why. Is int is not a float? I don't know. I wonder if we can, rather than watching 18 minutes of him going crazy, I wonder if we could just what we could do, we could fire up, this is a work computer, so I really don't have Python installed on this, but before I say that, let me just verify that. I don't think I have Python installed. We could try to find a Python interpreter. What is it? Interpreter online. That's what I want. So let me just see if I have. Yeah, replit into your Google. Okay. What's it? Replit. Try Python. No. Of course, I don't have Python on a work computer. That would make work too fun. Okay. Let's start coding. Am I logged in my GitHub? Yes, nice. Okay, and what we could do, we could create a replit that is Python. Cool. Oh, and I should have made that public. Oh, well. So here's the interpreter. So what was it? It was 0. 0 is 0 is 0. Syntax warning is with a literal, did you mean equals? If I did Python is, maybe is like equals. Python is keyword. Here we go. The is used to test if two variables refer to the same object. Print x is y. Oh, it's true. Okay. X. If I did x equals z. Oh, sorry, z, yeah. Z is not defined. So what if I did, just trying to see the, test things out here. So we've assigned, if I just do this, it should be false, right? False. So it gives you a binary true or false to see if it is, if it equals. So it's not assigning anything, it's seeing, is this that, or is keyword is used to test if two variables refer to the same object. I have this message here that I have low system resources. Can you hear me okay? Yeah, like a Boolean, exactly. Yep, okay. Interesting. Loud and clear. Cool, cool. This is what people go through these days. Can you hear me? Can you hear me? Can you see me okay? Can you hear me? Can you see me? Can you hear me? And then I get a message saying that they may not hear you. And so then you have to ask the Zoom live. All right, cool. So yeah, so that makes sense now. So which of these evaluates to false? That is not that, because one is an integer and the other is a float. Okay, so that makes sense. All right, we saved ourselves 18 minutes, sort of. Strings. Which of the following, what, oh my God, having a stroke. What will the following code print? For N in banana. I think it'll, interesting. For N in banana. Your question earlier was, is I an index? So either it's going to be this, it's either going to print out each letter, or it's going to print out two N's, because there's two N's in banana. So I'm thinking it's going to print out every single letter. We'll see if I'm right or wrong. Yeah. So yeah, it could have been I, it could have been N, you could have called it happy. I don't know if, I think you can use multiple characters rather than just a single character. And this is strings again. Strings are used quite extensively. All right. What is the value of I in the following code? So word again is banana. 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 Okay. So I equals word find. So this is actually going to give a placeholder, I believe. Or it's going to give us a binary. So anytime, anytime I don't know how something works in Python, rather than us watching a video or whatever, Google's our friend. So we could just do Python, and hopefully we can find some documentation real quick. So here, boom, geeksforgeeks.org, the find method. And they'll tell us exactly what's going to happen. The Python string find returns the lowest index of the substring if it is found of a given string. If it's not found, it returns -1. And you already answered it, which is 3. So it's going to be 1, 2, 3. It doesn't start on 0. We know that for sure. That's my only question here. Does it start on 0 or does it start on 1? This is, I don't know what the hell. They always want me to sign up for something. The output, result, it's going to be 0. Substring geeks. All right, well, let's see what you're saying. 3. I think it might be 2, only because most computer languages, it starts at 0, which is very counterintuitive. But it starts at 0, 1, 2, 3, all the way up. Why? I don't know. So I think it's going to be 2. You think it's going to be 3. Let's find out who's right. Let's see if it's 2. Yeah. No, that was a good guess, by the way. If you can just kind of keep that in mind, that's where a lot of people get tripped up, is like, especially with loops and walking through things. The assumption is, oh, everything starts on 1, 1, 2, 3, 4, 5, but not computers. They like to start on 0 because somebody thought it'd be cute to start on 0 for everything. So yeah, in this case, NA is a 0, 1, 2. So that is where it starts. And the second placeholder, which is actually the third placeholder in human language. All right. What is a handle? Reading files. Gosh, a handle, I think, is a fancy. How long is this video?
Hello and welcome to Chapter 7.
Let's watch this.
This is the chapter where it all really starts to pay off. We have been learning bits and pieces.
Sorry, let me just speed them up a wee bit.
And doing little 2 lines, 3 lines, 4 lines of code to learn the basic building blocks of Python and learn some of the syntax and find lots of terms. But now we're actually going to start doing something. So if you look at what we've been doing so far, you know, we're inside this little computer and you type up, the Python says what next and you give it its command and it does something and you do something else and does something. And you do this 3 or 4 times, unless you write a loop and then it goes like, 10, 20 times and that's it. And then maybe we write a thing that reads something from our keyboard, gives us something back, and then we write something that prints something out, print a few things out. And so we've been pretty much using the keyboard, the screen, the CPU, and the memory. That's kind of where we've been living. And while it's important to talk to the keyboard and the screen, the real world is things like databases that live out here, files that live on our systems, and connecting to the network and reading data from the network. And so that's what we're starting to do right now. Is we're starting to be able to work outside kind of our code and create things that are permanent. And so we're going to be talking, initially we're going to work on files. We'll later talk to databases and the network and other stuff, but for now we are talking about files. And so really we're stepping out a little bit and reading things that are permanent and creating things that are permanent. The kinds of files that we're going to talk about mostly are text files. And you can think of these as a sequence of lines in a file that are easily read by Python. You've been making text files all along. Your hello.py, that file's a text file too. You're using a text editor to create that file. You put your Python commands in a file, you run those files, and that's what it is. And so a file can be thought of as a bunch of lines, 1, 2, 3, 4, 5, 6, 7, a blank line here. That's possible. And but the reality is that these are actually just lines, and we have a special character called the new line that we'll talk about in a second. So to read a file, you have to call the open function. And open returns what we call a file handle. Open doesn't actually read the file. Open makes it possible so that you can read the file. So the parameters to open are, it takes one parameter that's required, which is the name of the file. Another parameter that's optional, whether or not to read it or write it. If we're reading the file, it doesn't harm the name of the file. Another parameter that's optional, file. Open makes it possible so that you can read the file. So the parameters to open are...
Sorry, I keep messing with you.
So to read a file, you have to call the open function. And open returns what we call a file handle. Open doesn't actually read the file. Open makes it possible so that you can read the file. So the parameters to open are, it takes one parameter that's required, which is the name of the file. Another parameter that's optional, whether or not to read it or write it. If we're reading the file, it doesn't harm it. You can read it over and over. If you write it, actually, if there's already data in that file, it truncates it and writes something. We're not going to really write files. We're mostly going to read them. And so open you pass it in a file, it gives you back this file handle, and then you have a variable in which you store it. I often call it fhand to be mnemonic. You'll see my code. I use fhand all the time to indicate that that is a file handle. And so if we were to run this in interactive mode, we'll open mbox.txt, and that is a function built into Python, and then it gives us back a handle. It does not give the data.
It's interesting. I've never heard I'm always learning something every day here. File handle. I've never heard it. I may have heard it, but I just went in one ear and out the other. Handle. I used to always just think of it as an object. You open a text file and you assign it to, I thought it was just like another object or a variable that had a glob of stuff. I've never heard handle before. So that's...
You can kind of see this when we print out the file handle using the print statement. It doesn't print the lines that are in the file. The lines that are in the file are sort of out there. There could be 10 million lines for all we know, lines in the file. The handle's like a little opening outside of your program, and you can talk to the file by opening it. Then you can read stuff. If you're writing the file, you can write stuff, and then you close the file to shut the handle down. But handle is a thing that allows you to get to the file. It is not the file itself, and it's not the data in the file. It's just a wrapper that kind of allows you. So this, if you print it out, it's like that's the file we opened. We're reading it, and encoding has to do with the different kinds of character sets, which we talked about at the end of the last lecture. The Unicode character set, etc. UTF-8 is a great character set. It's probably the most typical character set that you will run into. Although you can have different character sets of files, but most of them are UTF-8. So of course,
he just had to put in a little bit of jargon at the end there. That UTF-8, that's English. That's him saying that English. Any other encoding? Yeah, UTF-8. You see that everywhere, UTF-8. It's English, right? And the reason why they had to encode things is because of Japanese, Mandarin, and different languages, is that they'll have to use different encodings to... So that's where, if you ever hear Unicode or if you hear encoding, that's what that means, is what language is it in or what kind of typical coding is. I just associate UTF-8 as English, the English language, and not only English language, but the United States keyboard English language. It's kind of the standard.
Although you can have different character sets of files, but most of them are UTF-8. So, of course, this is Python. If you make a mistake and there's a file that doesn't exist, we get a traceback, and it blows up. We'll show you in a second how to deal with that. Now, the new line character is an important part of file reading. And in strings, we can put the new line character in by this \n character. And the \n is the character that indicates that we're supposed to go to another line.
Yeah, I'll just Yeah, to answer your question, Sean, is it like a language identification system? Sort of, right? I mean, I wonder if I have it. I don't know if I have TextPad installed here. Yeah, I wish I could show you. If you have TextPad, you can actually monkey around with a different encoding. It's how it the information is encoded. And like I said, it's like English language. I mean, there's like, it's a whole other topic that I'm not really that I'm not. I don't know a heck of a lot, but basically, in my day-to-day job, I actually, is it like area code for a phone number? No, not at all. Okay, so let me see if I can show you an example real quick. This is a good question. So what I, for my day-to-day job, I have to work on the mainframe. And it uses a language called Epsidic. I don't know if I can spell it correctly. There we go, Epsidic table. And so, you know, this was, let's see if we can kind of get this big. What's going on here? Come on, Google. Oh, maybe that's as big as it goes. Oh, I see. I thought that makes it big. It just goes to, anyways. So ASCII to Epsidic table. So on the mainframe, IBM created their characters called Epsidic. And then the rest of the world, when they made computers, personal computers for the rest of the world, they said, screw you, IBM, we're going to use ASCII. Now, ASCII and Epsidic, they actually this is a crazy acronym. I think ASCII stands for the American Standard. If you do a quick Google, what is ASCII? The American Standard Code for Information Exchange. So if we go UTF-8, that's an ASCII encoding. So here we go. UTF-8 is backwards compatible with ASCII. I thought it was with ASCII. And it can represent the standard Unicode character. So I don't know what the hell I'm talking about. Basically, all I know is that it's a way to present the information, not just to your program, but also sometimes to your operating system. Google to your heart's content here, but it really is, it has to do with, I mean, here's a nice little picture, shows you just like the differences, right? This is UTF-8, this is UTF-32, this is UFT-13, and it changes the character of each, right? And the reason why you would want that is for different languages. Yeah. Okay, so I've blown your mind. Okay. It's beyond scope for Python. What he was saying is that this is the most popular encoding. So if you have the option to do UTF-8, do UFT-8. Back here, what he's not really talking about, where was it? Yeah, handler here. Is that he kind of just mentioned this quickly, is that for Python, this whole file handler, this is kind of done automatically for us, right? So we're this example here where he said a text IO wrapper, name it this, do the mode R, which means read, encode it. I mean, you could do that. You could get it under the hood and start doing this. But if you set up, if you use a file handler, Python does a lot of this stuff by default. So you don't have to think about the encoding. I could be wrong on this. Maybe you do have to specify in a program, but I don't think so. I think his little example here is just fhandle equals the open command. It by default takes all this stuff. So we don't have to think too much about how is this encoded and are we using the right mode and all, like this stuff is done automatically. Now, if you get in a situation, where you had to do read write. I'm not sure how you would do that. And you might have to change the mode for a particular use case. Well, then, yeah, maybe you would have to figure out the different commands get under the hood. But if Python can do it for you, on
etc. UTF-8 is a great character set. It's probably the most typical character set that you will run into, although you can have different character sets of files, but most of them are UTF-8. So, of course, this is Python. If you make a mistake and there's a file that doesn't exist, we get a traceback, and it blows up. We'll show you in a second how to deal with that. Now, the new line character is an important part of file reading. And in strings, we can put the new line character in by this \n character. And the \n is the character that indicates that we're supposed to go to another line. Go to a new line. Go to a new line. And so we have, what is this? Well, that's a \n. That's a \n. And so if we print it this way, we see that the \n is in there. This is how we type it. We actually type \n to Python to indicate that we're supposed to put that there. But if we do a print statement, it actually interprets the \n. So the \n causes kind of this movement to the beginning. Now the print actually at the end of this adds another \n. So the \n that we put in by putting it into the string is that one, and then print always puts a \n at the end. There's actually a way to override that \n behavior by putting something on the print statement, which we'll talk about later. Now, it's important to note that the \n is one character, right? And so even though this x\ny prints this, and then print adds another new line to go down to here, if you ask how many characters, what is the length of this? Well, it's only 3. That's because that's a character, the \n is a character, and the y is a character. So it's a 3-character string. So the \n is a character like all the rest of the characters, but it's only, we encode it by typing \n. It's called an escape, where the / is the escape, \n is a way to say new line, because we can't see it. It's a way for us to encode in a string this non-printable character, this invisible character. The white space, it's part of white space. So as we're reading through the file, we can think of it as a sequence of lines, and we can read these a line at a time. We can also read them a character at a time if we want. And so, but it's more common to say read this line, read the next line, read the line after that, et cetera, et cetera, et cetera. But the way to best think about this, it doesn't really matter. You can think about it as lines, and we will in most of the programs that we write. But realize that the way when we see this, we see it like this. It comes back to the beginning. It comes back to the beginning. There's a character in the file at each of these points to say go back to the beginning. It's like hitting the enter key on your computer, and that is a new line. So you have to think that in the file, in order for your text editor and Python and everybody to know where the lines end, you put new lines in the file, and that's another character. So this looks like an empty line. This line here looks like an empty line, but really it has a single character, and the character is a new line. And it turns out that in a bit we're going to need to keep track of the fact that every line is ended by a new line. So up next, I'm going to talk a little bit about how to read files in Python.
Cool. Okay. Yeah, it is him. Charles Severance. I get made fun of my last name is Gamble, but Severance. I'm sure he has a heck of a time at work with that name. All right. Here we go. So now that we had all that information, what is used to indicate a new line in a string? And it is the \n. So there's a whole bunch of these. It's not just the only one. I forget. You'd have to look at escape keys. I'm thinking there's one for new line, and then there's one to actually indicate a character return. But I'm thinking that should be the same thing. So I don't know. Let's just do real quick here. Python, not CPython. That's a whole other. Escape characters. I'm gonna just see if there's a lot or quite a few. There's only a few of them. So \, single quote, \/ for \. There's the new line one, character return. That's the one I was thinking. So I'm kind of confused on the difference between, this is where it trips me up. Hello, our world is the same as N in my eyes. Anyways. So yeah, there's a few of them. I didn't know how many there was. Tab, \, form feed. Here's another one, form feed. Oh, no try button on that. Octal value, hex value. Octal value. What's that one? Hello. Oh. So it's getting the octal value of these characters. All right. I guess that's handy in some scenarios. Files as a sequence. What does the word continue do in the middle of a loop? I'm just going to take a guess, but I think it continues to the next line. Let's see. Skips to the code indirectly. Sorry, skips to the code directly after the loop. No, I think that's what a break does. Skips to the next line in the code. That's what I think it does. Skips to the next iteration. Skips to the next block of code. So I'm thinking either it's this or the next iteration. Let's see what iteration. Yeah. So if you were doing a loop and you wanted it to just go to the next loop, you could use the continue keyword. Back when I had to make something for work, I had to make a little search engine or something. And anyways, I just wanted to skip through all the nonsense till I found what I had. So I did, and it wasn't in Python, but it was in a language called Rex. They're almost made for this. They've almost made this electrician proof. No way. No way. That's hilarious. Yeah. If you want to just skip through a bunch of nonsense and just get to the next loop until you find what you need, you could definitely use the continue keyword. So hopefully that'll be helpful down the road here. What is the value of X after running this code? In this section is for lists. Okay, so lists are an interesting topic. They're almost like arrays, but not quite. So fruit equals banana, and then X equals fruit 1. So what is the value of X after running this code? It is that's interesting. It's not a list. 0 equals B, so 1 equals A. Yeah. Slicing. No, they're talking about a list here. Might as well go through this.
Hello and welcome to Chapter 8. We're going to talk about lists in this chapter. Up to now, we've been talking about algorithms. Algorithms are the concept in computer science of using a programming language to express the steps that you want the computer to go through to solve the problem. Read some data, convert it to a floating point number, check to see if it's greater than 40, do one thing if it's greater than 40, do another thing if it's not, then print out the result. Or open a file, read everything. If the first line starts with something, do something. If not, skip it, and then add all the things up. Those are steps. Those are a series of steps, and hopefully by now you're getting to the point where you have a good understanding of steps. But there's a whole other side of computer programming, and we call it data structures. And data structures is not the steps, but instead clever ways that you lay out the data, and clever ways that you make sure that the data does what you want it to do. And so that's what we're going to start talking about now. Lists are the first and the simplest data structure. Strings are kind of like data structures, but lists are probably our first real data structure that we're going to think about and design and make use of effectively. But before we talk about what is a collection, we should talk about what is not a collection. So we're familiar with what a variable is. We know that a variable is a little piece of memory that's got a label on it, and then an assignment statement, sticks a 2 into X, and then 2 is in this little cupboard, and then it goes to the next line, and then 4 goes into X, and so the 2 goes away, and the 4 is there.
I think I know what you were saying, because I was looking at your answer here, and you're saying 0 equals B and 1 equals A. So it may be. I see what you're saying. Each letter might be part of the array, but I don't think so. I think
a key thing is you can't have more than one variable at any given moment, right? And more than one value in a variable. So when we move to collections, collections are more like suitcases. We can put lots of things in them. We have ways of organizing them, and as we go through lists and dictionaries and tuples, we'll see how there are different ways to organize them. And as a matter of fact, we've been talking about lists for a while. Every time we use one of these square bracket syntaxes in earlier programs, we've been working with lists. And so this is technically a 3-item list with 3 strings, got commas here. Joseph is one string, Glenn and Sally are another string. And here's another one that is another thing. And the list is basically, it's a list constant, and it's being assigned into a variable. So this friends variable has 3 things in it. So that's different than what we've been talking about before. So these bracket structures with square brackets are those lists. And so the print is just a print with parentheses to get the print to work. But 1, 24, 76 is a 3-item integer list. Red, yellow, and blue is a 3-item string list. But it doesn't all have to be integers or strings. Python can handle different things and different kinds of data in different.
Okay, so yeah, I was getting tripped up here. Most languages, they use the word array. So I'm just going to do a quick Google search. Or list. I'm just wondering, is there a difference between array and list in Python? Python does not, according to some random person, Python does not have native array data structure, but it has list, which is mutable, which means we can modify the content present within the list. We can store data of heterogeneous data types, much like more generally used as multidimensional array, quite easily. Huh. Interesting. I don't know. I'm getting kind of tripped up here. Python list array methods. Here we go again. Python does not have any built-in support for arrays, but Python lists can be used instead. Okay. So yeah, I was getting, is that what they call an argument? Yeah, an argument. So in this case, I think you're absolutely right that if we're treating if fruit is in fact a list, but I don't think it is because it's not surrounded by the square brackets. But maybe in the rest of this video he mentioned something about you don't need the square brackets. So let's just give him the
positions in the list. So red 2498.6, a 3-item list with a string, an integer, and a floating point number. And while we're not going to use this too much for now, this outer list is a 3-item list, and the second item,
NumPy and pandas, is definitely done. Is for Python arrays. You're asking beyond scope for me. I know NumPy and pandas is definitely done for data wrangling and for data usage in Python, but as far as for arrays, because we did see that, you did see that in one of the Google searches, how somebody imported it from NumPy. So maybe it, some of those references we were saying, there's no built-in array method for Python itself, but you can always, yeah, exactly. So you could still import something from another. You can always import other functions or other, I almost want to say like products, but that's not right. In JavaScript, especially Node, there's always these dependencies, and basically you're importing different functions from different whatever libraries. Yes, thank you. Struggling with the words. So yeah. I think
is another list. So this is kind of alluding toward what we'll do when we start talking about data structures. And that is, we have a structure and then we have another structure inside of it. And sometimes this can get quite complex. And we're doing this for a reason. This here has no reason, just to show you that it's possible that lists can be made up of lots of things, including other lists. And of course, there is also the notion of the empty list. And like I said, I have had to be able to tell you about lists all along. We use them in for loops. We can put lots of things here. We can put file handle here. We can go through the file. We can put a string there. We can go through the characters in the string and in a list. And the iteration variable then goes through the successive elements of the list. And that's why this prints off y 4, 3, 2, 1. And then the loop is done and it prints out last off. So we've been using them and we've been actually iterating through lists with for statements all along. So the for statement, has been something we use with lists. And when you just need to go iterate through the list and go through every item in order, the for is a great way to do that. So friend is our iteration variable. Friends is our list variable. And so that says friend is going to successfully take on the value Joseph, Glenn, and Sally and print out, Happy New Year, Joseph, Glenn, and Sally. It runs 3 times, once for each of the values, and the iteration variable advances. Now, I do want to make it really clear that the choice of friends and friend singular and plural is arbitrary and capricious. It happens to be convenient and intuitive that the iteration variable is 1 and the list variable is more than 1. But Python has no idea about singular and plural. As a matter of fact, Python would care. It would be totally equivalent for Python to do the same thing. They have the list variable be z and the iteration variable be x. X will take on the successive values of these 3 things. Now, am I being nice to you by calling this list friends and this iteration variable friend? I am, but I also don't want it to confuse you if you're just a beginning developer. So, just like strings, we can sort of look within lists. Part of the thing is when you put more than one thing in a data structure, you need to get them out.
So I was wrong. Yeah, it doesn't know the difference between singular and plural. That's good. He was saying, yeah, Python doesn't give a rat's arse. So we could have used it as whatever, right? Interesting. Yeah, we could have named that X or Bob or whatever the case, and it still would use it almost as kind of an index variable.
So, just like strings, we can sort of look within lists. Part of the thing is when you put more than one thing in a data structure, you need to get them out. And so lists have positions, they maintain order. And so the first thing in the list is the sub-0 position, sub-1, sub-2. Just like strings, they're 0-based, just like European elevators, they're 0-based. So if we take a look and we say, oh, friend sub-1, that's how I read that. The little square brackets, when you take a variable here and you say friend sub-1. Remember, singular and plural don't matter. Friend sub-1 means Glenn, because this is the 0 and that's the 1, and then Sally's the sub-2. And so that's what prints Glenn out in this particular thing. Now, lists are mutable. Mutable is another word for changeable. They can be changed, meaning that a list has 3 things. You can change this thing right.
There we go. So there it is right there. There's the answer. So yeah, I didn't realize that a single string could be a list. I mean, we could watch the rest of the video real quickly, but yeah, the answer is what you said, whatever it is.
In the middle if you want. To take a look at what's not mutable, strings are not mutable. So if I take a look at assigning banana into fruit.
Oh, you know what? I got to start reading carefully. So hang on. So this is exactly the example there. They're saying, no, fruit equals banana. Okay. gotta watch
fruit. Well, fruit sub 0 is a capital letter B. Could we imagine for the moment that we could change fruit sub 0 to lowercase b? Well, the syntax would be how you do it if you could do it, but it turns out that strings are not mutable, meaning they're not changeable once you create them. And that's why when we do things like lowercase or uppercase, we take a look at the fruit and we say, give me a lowercase copy of that, and then we take the return value from this and we store that in x, and that's how x becomes a lowercase banana. But fruit is still the original one, so fruit has not changed. Compare and contrast that with a list, though. Here we have a
you're on the right track, and I thought you were correct as well, but this particular example, what he's showing us, and let me just go to full view here. So this is not the same at all, but he's saying fruit equals banana, and then we say I'm almost thinking I'm thinking you're right that it's this, right? Because it's saying 0, 1. So I'm thinking it's A. It's just odd to me, right? Because he's been showing us examples of square brackets. So I think you're right. Yeah, you're right. You were right all along. So I guess if you had more than one value, I guess we can skip the rest of the video here, save some time. But yeah, I didn't realize you could just get away without using the square brackets. So that's interesting. And this one is working with a list still. Is something in the list. Okay, so which method is used to add an item to the end of a list? That is append. I think it's append, but I've also seen push too. Push it to the end of the stack. Yeah, append. I think it's append. Yep. All right. We know what we're talking about. Okay, so what does n equal in this code? Words from SQL. Excellent. Words. His email is Quincy Larson at freecodecamp.org. Pieces. Words split. So you start splitting these up. Parts equals pieces. So this is making a list of this. Pieces is the fourth placeholder. So this is 0, 1, 2, 3. Parts equals pieces. So go to the third one and split it with x. N equals parts 1. Okay, we have to watch this.
So now we're going to wrap up and talk a little bit about how strings and lists are related. They're sort of related in that they both have zero-based things, and we use the square bracket operator to do various things. But there's a lot of situations where we're looking at our data and we're combining the use of lists and strings. So let me show you the first thing, probably the coolest thing. We're going to use it a lot the rest of the class, and that is the split function. So let's take a string. We've got ABC here. It's with 3 words. What we're interested in the fact is that there's spaces in this word. And what split does, it says, I'm going to look through this thing, I'm going to find this, and I'm going to break this into pieces, and I'm going to return you a list of the separate individual pieces. So look for blanks and break it in pieces and give me back the pieces. So I'll print these out, and now you see that it's a list with 3 items, with 3 words. The spaces are gone, but it's given it to us. So it's like, split this into words, please, and give me the individual words, and give me a list of individual words rather than a big long string with spaces in the middle. And that is a quick way to go from a line, and it's really common. A lot of things are going like, go get the second thing or the third thing or whatever. So the split's really nice because then you can just grab stuff. And so you say, oh, how many things did I get? Well, I got 3. The len function tells us that. And I can print the first word I got, which is with the sub 0, and that'll be like with will be the first word because that's the sub 0 position. So I read something, I split it, I can say there's 3 things, and I can look at stuff the first word basically without really knowing much. Now, if you remember earlier, and we'll see this, we used find and slicing to do a similar kind of thing, but people tend to prefer the split. And you can oops, go back. You can also then loop through them, so you can split these things into stuff as a word, and then go through with W, and then it's going to go through W is going to take the successive with 3 words, and so you can make a loop by reading some data, splitting it, and writing a for loop, and then it's effectively going through the words in that line of data. And so that's a really powerful concept that we'll use in a lot of the programs that we're going to write. Just a couple of bits about this and how it works. Split with no parameters here, it looks for spaces, but it also treats a bunch of spaces as a single space. And so it's pretty smart about that. And so even though this has a lot of spaces between lot and of, you only see lot of, all the spaces are gone. It does something special about spaces. It's really white space, so tabs or new lines or other characters would also qualify in split, basically. Now, you don't always have to split based on spaces, and a lot of data that you're going to run into, you're going to want to split on something else. And so here's some data that looks like we're using colons to separate the first, second, and third piece. Now, if you just call split's looking for spaces. And so split gives you back a list of the things broken apart with spaces, but there's not a single space in that line. And so we get a list, see it's a list, but there's only one item, and the semicolons are sitting there. Split doesn't go like, whoa, this looks like it should be semicolons. Split's job is to use spaces and split the string based on spaces, okay? But
given that this is something we like to do, you can tell split what character you'd actually like to split on. Now, it's not quite as clever when splitting on something other than spaces. It doesn't understand that, if there's a bunch of semicolons in a row, it still thinks of those as splitting points to split. But in this particular case, where there's no spaces, it's going to split that. So it says split this based on the semicolon, instead of being based on the space. And so if you take a look at what comes out of this, we split on semicolon, now we have a 3-item list, and we get first, second, and third. And a lot of your data comes out of some logging system or some router status updates. Who knows what you're looking at, but the delimiter is often something other than space, and you can do that with split. So this is a useful thing when parsing things like our email address, right? We wanted to get things like the email address, this second piece, off of the line. And so we can use split to take advantage of this. And so here's a little loop that's just going to print out not the email addresses, but instead the day of the week. We're going to print the day of the week out for all these things. How do we do that? Well, we can observe really quickly that if we split based on spaces, it's the 0, 1, 2. It's the 2 positions. So we can quickly write a bit of code that opens the file, then loops through the lines. We do this all the time now. Strip takes off the end of the new lines. We can check to see if it starts with from space, right? From space is our key, so we're ignoring all of the lines that don't start with from space. But then we find a line that starts with from space, and we split it, and then we just print out the second word. And so we get the second word of the lines that start with from. And that's how this.
So there you go. There's that continue. I know we skipped a bunch of videos, but there's that continue. Exactly what he's saying. If it's not this, boom, go to the next one. Go to the next one. Keep going until you find what you're looking for.
Then works. Now, sometimes we want to dig into it deeper, and we will take something, split it, and then split another piece of it again with a different delimiter. And so let's just say that the thing that we want to achieve is getting the part after the @ sign for email addresses. And we did this with, again, find and pose and stuff like that, but you can use split to do this as well. So the first thing we're going to do is we're going to take this line, we're going to split it based on spaces, right? Chop, 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 chop. And the fact that there's an extra space there doesn't matter, split happily just like zooms through that. And then words sub 1, 0, 1, 2. Word sub 1 is this email address. So we'll put that in a variable called email. And so email will be a string that's just this. So in 2 lines, we pulled out the second address into a variable. Then what we're going to do is we're going to re-split that. We're going to take this string we've got and split it based on @ sign because we know it's an email address. So we get a new set of pieces. The first part is the person's name, and the second part is the host name that their email is hosted on. And then what we can do then is we just happen to know that this is the 0 item and this is the 1 item, so we can get at that. So the interesting thing of going here, if you think back to how we did this before with find and pose and all that stuff, it's really a lot cleaner. And we don't. For me, I can look at this after you understand it, and it's easy for me to understand that it's correct. Whereas that pose stuff, you got to add one and start the second find after. Just remember that. And this is a lot cleaner way. And this is a more typical way of pulling this kind of information out of a line. So in this chapter, we talked about lists. We talked about the concept of collections. That's our first data structure. We're not just doing algorithms. We kind of know algorithms now, but now we're going to do data structures. And this chapter and the next 2 chapters are our foundational data structures. And then we'll, like everything, we'll make more complex data structures by composing those data structures together. We looked at how strings and lists connected together.
Okay, thank you there. Charles, if that's his name. Sorry, what did you say on the chat? Is the purpose of coding to not repeat yourself in the program to keep it cleaner and shorter? Yeah, that's actually one of the programming principles. You want to try to, it's for performance. Performance for one is, I would just say performance for one, in that it just logically, if you read it back, it's a good question. I would say it's both. You want the code to make sense. You don't want to go through unnecessary steps. And it's also for performance. Now we're dealing with such small data that it's like, who cares? But if you were dealing something like, say you had something that had like 10,000 records, and you were going through each letter of each of those records, like you just might make your system crawl to a halt. Where if you're already starting to see, like, is there any information in this record? And you're like, no, go to the next record. It'll speed up the performance of your program. Your computer won't just crawl to a halt because you've just skipped unnecessary cycles. You can make the computer crawl by going, letter by letter and doing some calculations, or you can just see, is this even the record I need? And just kind of to skip through. I haven't worked on with a heck of a lot of data that was like huge data sets of sorts, but there have been in the past, I've kind of dealt with situations where just by adding a quick step to skip a loop, or to kind of like just to speed up my search, it made the whole program go faster. So yeah, it's both. And when I look back, I was like, oh yeah, I didn't need to look through the entire record. I just need to find this one chunk. So yeah, it's definitely both to make it easy to read and to skip. Okay. I'm glad you love coding. I like coding too, especially when it works and it makes sense. It's like, oh yeah. It's definitely a puzzle piece that's fun. All right, so back to this challenge. Now that we got all that, he's talking about a double split. So the pieces is going to split all this based on spaces. So his email is, and then the email address. Now this wants us to go to the third piece, which is correct. So this is 0, 1, 2, and then this is number 3. And he wants us to split, excuse me, the Q, and because so Q is going to be in the first placeholder, or sorry, the 0 placeholder, and then 1 is going to be this. So the correct answer is that. It's less shocking than electricity. I can imagine. I've heard stories from electricians, and I tip my hat to you, good sir. It's yeah, high voltage. Just as you know, as a young kid, one of my uncles, he worked for, I want to say Ontario Hydro or whatever it was called back in the day, and somebody that was telling him there was a pole dancer. Yes, he was a pole dancer, and it was dreadful. Really, he was told that there was no juice going through whatever, right? And he had his left foot on the box, and he grabbed it with his right hand, and boom, it blew him right off. Electricity went from his left hand, and it got grounded out that foot. So he like blew his ankle out, his left foot, and he actually lost all 4 fingers on his right hand. Now, I didn't know him. Did he live? Yep. It went, it missed his heart. So, believe it or not, yeah, I don't know if they resuscitated him or whatever the case may be, but it's lucky. Yeah, no shit. Yeah, it was his left foot. So just by the luck of it, right hand diagonally to his left foot. So as a young kid, I saw somebody that was very close to our family missing 4 fingers and hobbling around. And you know, he's lived with it for more than half his life now. So he's adapted or whatever. But at a young age, it's like terrifying. Like, oh wow, you know, that's what electricity can do. So try popping a paper bag. He would kill me. He would find a firearm and he would shoot. No, he's actually pretty easygoing. He wasn't until he retired. And then he became pretty chill kind of guy. So yeah, he definitely had some stories. You should see him climb a ladder still. Holy Jesus. He just, whoop. And then at the cottage growing up, we did see him put on the spikes and climb up a tree. It was crazy. It was crazy to watch. All right. So we're going to try dictionaries. Dictionaries are like lists, except they look just a little bit different. Dictionaries actually look like JSON. If you ever hear JSON, JavaScript object notation. So this is what a Python dictionary looks like. You wrap it with these curlies, and then you give these are keys, and then these are values. And if we just did I think JavaScript. Actually, we could just do JSON example. So this is from the same website. It looks almost the exact same. So JSON and dictionaries are interchangeable, but Python, it's more specific because everyone has to have their own language. So what's this say? As if Python 3 dictionaries are ordered. Dictionaries are unordered. Oh, I did not know that. And we could try this ourselves. Let's just try. It's going by key here. It seems like B. I wonder if we could just mix it up just for fun. I guess it depends on the Python version they have. No, so it took my order still. So that's interesting. This little factoid. I didn't know that. And that looks like that's recent. Can you save them as a JSON? It's interchangeable, right? It's like, can you save Word as a string? Like it's kind of the same thing. Where it would be relevant, your question is if you had a Python program talking to somebody using JavaScript, yeah, you would send it as a JSON, a JavaScript object notation. I think that's what it stands for, object notation. Yeah. Anyways, back to our purposes. Look at all the, wow, we've talked and Googled quite a bit here. It's like a runaway train here sometimes. Okay. So in this case, since we kind of know what a dictionary looks like, what does the dic equal after running this code? Okay, so dic, we have this key Friday 20, Thursday equals 6, Saturday equals 1. Sure. Then we assign a new value to Thursday, so 13. Saturday is now 2, and Sunday is 9. So this is the answer. We have a dictionary, and then we went to the dictionary and assigned new values. No. What am I missing here? What did I do wrong? Saturday is 2, Sunday is 9. Huh. Did I miss something? No, it's not just you with the tabs. I'm wondering. What does dictionary equal after this code? Maybe it equals this. Maybe it's rather than, see, my assumption was that we were referencing Thursday, but what we might be doing is just appending the exact same values, or sorry, the new values to the end. So I think this is the correct answer now. No, you're saying it's number 4. Friday is missing from your append. Oh, thank you. Gosh, even when it's right in front of me, Friday is missing. Yeah, sorry, you're right. Gosh. Okay, so Thursday be, so it's this one. Yeah, okay. So this one was assigning new values to the Saturday and Sunday, and then it was adding the new object that didn't exist yet. And it kept Friday as the original. Okay, good eye, good eye. You're on top of it. Okay. You want to go until 9:30? Yeah, man. This is fun for me. Dictionaries, common applications. This actually might be a useful video to go back, but let's see if we can just crack the. What will the following code print? Count. So we have another dictionary. So print count get Chris equals. Sorry, Chris. So there is no Chris. That's funny. I'm seeing these names here. So Quincy is if you ever help out with freeCodeCamp, you start to see the same names over and over again. I don't know who Bo is, but I've seen Mr. Mugrish. He helps make freeCodeCamp. So I kind of chuckle. I've talked to Quincy a few times. He's really cool. And Mugrish, I've talked to him a few times. He's really cool as well. Bo, I don't know if that's a real person or if they just use that. So it's kind of cool that they're actually using the people that built freeCodeCamp. They're actually putting them in the examples. Anyways, so print count gets Chris 0. I think this will return an error, is what I think. Nope. They are lucky to have talked to you. I know how. You're filling my bucket. You're making me feel good. I appreciate that. No, they're really, I only dabble on this when I have time. So 0? Interesting. I don't know why it was 0 here.
So now we're going to talk to you about one of the common applications of dictionaries, and that is making histograms. It's counting the frequency of things. And so if you think of a histogram as, it's a little graph, and there is, how many A's, how many B's, and how many C's, and there's histograms as, there's this many of that, and this many of that, and these are like buckets. These are frequencies, and this is how many times it happens. So a histogram. But we're going to do this thing where we're going to count people's names, and we're going to kind of count how many that we see. The interesting thing that we're going to solve, just like many things in the computer, is we can't just sort of look at the data. We've got to look at the data iteratively, one piece of data at a time. So I'm going to give you a little problem. Okay, I'm going to show you a series of names, one at a time, and I want you to count for each name, make a little bucket, and then keep counting how many things for each of the different names. Okay, you'll notice that you have to start with one, and then you move across. So just watch this and tell me what's the most common name of the set of names I'm about to show you, and how many do we see?
Okay. This is sped up at double time.
So what was the most common name and how many times did you see it? That's the question. Now, here comes the reveal. So for humans, it's so much easier for you to just look at this. And you think, how did my brain look at that? And you're like, okay, what is pretty common? Oh, maybe Chen is common. Oh, Chen. No. Maybe Zhen is common. 1, 2, 3, 4. Yeah. Anybody else? Marquardt's got 3, C7. And so you'll notice how our minds, without computers, we just sort of like bounce, branch and bound. We have hypotheses, and then we decide, it's Zhen. That's it, and there's 4 of them. Now, how did your brain think about this as we were going through them one at a time? Well, my guess is if you really had to do this a lot, you would make a little picture like this. And then what you would do is if you saw a new name, XYZ, you'd add it to the list and give it a tick mark of 1. And then if you saw like C7 again, you give that a tick mark. And if you saw XYZ again, you make a tick mark. And then you keep adding to these tick marks, right? And that's how you do it. And you wouldn't, like many of the things we do in a loop, you wouldn't really know what the most common was until the end. And then you sort of take a look at these numbers and you say, okay, that's the most common number. And then you'd be done. But you have to watch them one at a time. You can't just bounce around. And so that's how we're going to use dictionaries to achieve that. Again, instinctively, as humans, we just look at this stuff. But if you got a million things, you probably want to write a Python program and use dictionaries. And so this is the idea. And there's 2 basic things that happen. One is the first time you see a name, you say, is this name there already? If it's there already, you really just want to add 1 to it, right? That's the adding of a tick. Or you want to see for the first time, blah, 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 and give it a 1. And so you can.
Okay, well, let's just slow down here. So CCC equals dictionary. And then CCC equals 1 print CC. So that would print out, because we've added these 2. Okay. And then this one, he's saying CWhen equals CWhen plus 1. Okay, yeah, that's pretty straightforward. So now, okay, that makes sense. Does that make sense? They do the little tally here and then, okay.
Use the name as the key, and then 1 is the value. And then first time you see Chen, you stick 1 in there. And so at this point, inside the dictionary, sort of dynamically adding as soon as it sees a new name, it adds another slot in here. But then if you see the same name again, like Chen again, then you end up with a 1, add 1 to it, and so it's 2. And so at that point, Chen is 2. And so you can see how you can both extend the dictionary by encountering a new name, or adding when you see a name that you've already seen before. The problem with dictionaries is, like everything in Python, there are rules about what you can and can't do. And one of the, I think, kind of frustrating things about dictionaries is that you can't just look for a key that doesn't exist. So this is a fresh brand new.
Like an auto counter, yes. Sort of. It's not auto. I mean, you would have to write the code to search if you had a match and then add it to the dictionary. So it's not. You would have to do a bit of setup to do the counter, but yeah, you could set up like an auto counter. Oh, look at this. It's not a function you have to make. Yeah, correct. Yeah, exactly. So this one, dictionary tracebacks. So what he's talking about here is if you try to reference something that doesn't exist, is an array of reference for a key in which is not in the dictionary. Okay, and we use the in operator to see if a key is in the dictionary. So in this example,
dictionary, we do a constructor there, and we print out some C.
Sorry. So here he it looks like he just made an empty dictionary, and then he's trying to find a value that doesn't exist, and then it fails. What you could have done to prevent that traceback failure is to do what he did here: is check if this is in that, and if it's not, you'll get a false.
And boom, it blows up, and that's bad. But we can solve that by the in operator.
Yeah, I did see those files. I'm actually try to download them myself here. Thanks, man. That's awesome. Yeah, that data wrangling I had a lot of fun with, and the test driven with Python. That's awesome. Thanks, man.
operator we've used in the for loops, we've used it in lists, we've used it in strings. So that is a question. It's saying, is C7 in CCC? Well, this is this empty one, and so it is, no, it is not. C7 is not in CCC. And so using this in operator, we can avoid the traceback. We can say, if it's not there, put it in. If it is there, add 1 to it. And that leads us to this bit of code, okay? And that is the kind of code that we're going to build a history. This is going to histogram code, okay? And so this is going to have name as our iterator names. Sorry, I made them singular and plural. That's nice, but so name is going to be C7gen, C7gen. Now, normally we'll be reading this from a file, but for now, keep it easy.
Okay, whoa. I'm sure he's going to walk through this. Let's see here. Counts equals dictionary. So it's an empty dictionary, and then we have names in a list. And then we say for name in names. So this could have been named anything. So we're walking through the list. If name not in counts, so you're checking to see if this name is in the dictionary, counts name equals 1. So this, your question of how to make this, that counter that he was talking about, this is the code right here, is that you have a list that you throw at your little counter here, your counter dictionary, and then you would start tallying it up. So in the case of, if you were doing data wrangling, so if you had a whole list of names and you wanted to like go through that whole list of names and see how many hits, this is essentially the code that you would create to see if there's a hit. Okay, add it to my dictionary and give it 1. Yeah, I think that's how it's going. Yeah, pure English, exactly.
Easy. We're going to go through this. And we're going to have counts as our dictionary. So that starts out empty, and we're going to do a simple if then else every time through the loop. If the name we're looking at is not in the dictionary already as the key, then set it to be 1. If it's not, go get the old value, counts of name, and then add 1 to it and stick it back in. So this line right here is new, adding a new thing, and this line right here is adding some things to existing things. And you do this long enough, you start with an empty one, and you do this long enough, at the very end, it will print out the histogram that you're looking for, And so you say, oh, we've seen C sub twice, gen once, and gen twice. And so that's the idea. And so this can run a million times if you want. Now, this notion of checking to see if a key exists and doing one thing if it doesn't exist and doing another thing if it does exist is such a common practice that the dictionary object has this method called get that collapses these 4 lines into 1 line. And so the idea is you're going to do one thing if it's in there and you're going to retrieve the current thing. Otherwise, you're going to pick a default value. In this case, we'll pick 1. Pick 0. This is like the default, right? Meaning what is not there. And if you say counts, now counts is a dictionary. .get, that's like string.upper, that's a method. You give it a key and then a default. And if the key exists, you get back what's in the key. If the key doesn't exist, you get the default.
Okay, so yeah, I don't know if he said it there, but basically you could write these. Yeah, he basically said you could like it collapses it. So you could write 4 lines of code or you could write a single line of code. And I'm seeing this a lot with JavaScript is that there's this new thing called, it's always referenced as ES6. I won't even get into it because I won't even do it justice. But basically, they introduced a few years ago these fancy functions. And a lot of these fancy functions do exactly what this example is doing. And I'm still trying to learn these fancy new functions every time they're introduced. But basically, rather than writing more lines of code, you can just compact it into 1 line. I don't know what it does performance-wise. If it's already built in, why not use it? Rather than doing 4 lines of code, now you have only 1 line of code. Depends how easy it is to read, right? If you didn't know that get did exactly what this does, then it might be confusing, but yeah.
Okay, so, and with no traceback, this works. So the best way to think about this is those 4 lines are equal to that 1 line, because X is either going to be whatever was in there before if it exists, or it's going to be 0. Now, the nice thing about 0 is the next thing we're going to do is we're going to add 1 to it, so that's going to get us to 1. So collapsing that loop that we saw before, collapsing that loop, we can make it just a 1-line loop, and this will become an idiom. This will become something that you will get used to, and you will use over and over and over again. And after,
all right, so let's just go through this again. So you have your dictionary, you have your list, and then you walk through the list again, and counts name equals counts get name. So the default is 0 if it doesn't exist. If the name is there, add 1. That's what I understand. So we use get and provide a default value of 0 when the key is not yet in the dictionary. And then just add 1. Okay. I think. Let me just look at that previous slide. If name in counts X equals, you add the name. else x equals 0. If count, the more I read it, the more I'm like,
we saw before. Collapsing that loop, we can make it just a one-line loop, and this will become an idiom. This will become something.
So once you get the concepts and basics of a language, it's easier to learn many others. Oh yeah, man. Yeah. The first computer language I dabbled with was in high school. It was called Pascal. And that's when I was introduced to variables and kind of some of the loops and all that stuff. Didn't really take any other computer programming. I kind of dabbled here and there a little bit, but not much. And then in Georgian College is what I majored for, a computer programming analyst program that they have. Were really good. They just kind of threw Visual Basic at us. And it was a little overwhelming. But then when I learned, then we started learning kind of HTML is a little bit kind of different from other languages. But when we had to learn Java, then we had to learn JavaScript, and then we had to use C and C++, and then even going back to assembler, which is old school and it's a little bit more low level. They all had the same concept, right? You're assigning variables values, you're looping through things, or you're executing stuff, or you're reading data. It's the same thing, kind of done differently. I'm fascinated, like this little chunk of code here. I'm looking at it going, okay, and I'm trying to walk through it going, okay, yeah, this loops through that, and this is assigning that. I remember going to a computer camp school for 10, got to 20 for Tandy Radio Shack, and it was 10. Got to 20. 10, go to 20. So you can go, was the commands. Oh yeah. Yep. That's exactly it. Yep. That was and that was especially in assembler. It was like go to this line, execute that command, and this and that. These like Python and some of these other languages are considered like high level, but yeah, they kind of do the same thing over and over again.
Thing that you will get used to and you will use over and over and over again. And after a while, right now you're looking at it, boy, that's a lot of syntax and semicolons and whatever. After a while, you just type this and not even think about it. It's an idiom. It's basically included in this idiom is how to both create new entries in dictionaries and update existing entries by adding one to them. So everything else in this is the same. Name is going to go through these 5 values. And we're going to say counts of name equals counts.get name.
Okay. Just going to slow them down here because I want to hear this. I'll slow them down a wee bit here. I want to see him walk through this.
Everything else in this is the same. Name is going to go through these 5 values. And we're going to say counts of name equals counts.get name, comma 0 plus 1. And so if, for example, this already has a 1 in it, then this is going to be 1 plus 1 becomes 2. If it's not, it's going to be 0 plus 1 equals 2. And so this is the idea of if new, set to 1, not 0, set it to 1. Because the first time you see something, the count should be 1, not 0. So that's why we make this default. Now the get can be used for anything. It just so happens that 0 is a common default because it's really common that we're using this to basically make a histogram, right? A little histogram of A, B, C, right? And so we need to make a D, but then the histogram has to start at 1. So that's basically the simplified counting with get. And there's a lot of things that we're going to do inside of Python that do have to do with frequencies and how many times certain things happened. And this pattern is a really good pattern to absolutely know.
All right, there you go. A pattern. We learned a pattern. All right. So let's see if we can do some of these real quick here. So what will the following code print? So if we try to, and we said it was 0, right? Because get Chris is going to add Chris with a value of 0 is what I got out of that. So the answer will be 0. Chris will have the value of 0. Okay. Let's see if we can do a few more here. What will the following code print? Counts. So we got the same kind of a dictionary setup for key and count. So kind of index and count. If counts key, so if the key, so this is the key, they could have used a different word, to be honest here. if the value is greater than 10, print out key and then counts key. God, this is some horrible naming in my advice, but anyways, because this is the key and then this is the value, and so this kind of throws me off when we say this and that. So anything above 10, yeah, you're right. Number one, absolutely. Truples collection. Oh my God, truples is a whole kit and caboodle here. Truples collection. Huh. A tale of two sequences. Let me see. Let's just see if we can do this. And then try to backwards. What will the following code print? So we have D equals dictionary. So Quincy equals 1. Bo equals 5. Chris equals 9. For K and I and D items, print KI. So I'm thinking there's going to be 3 items. That's interesting. K. One. Yeah, I'm thinking you're right. No. What's this? What's this link you gave me here? Oh, shoot. Does the link not work here? Let me try this link. Python truples. Gotcha. Why is it? Oh, got to listen to
So now I'm going to show you how I use Grammarly to edit. Okay, so here's my essay, and I'm going to...
All right. This is for my benefit.
Let's do this 1,000,000 times. The output of this function will be the time it takes to make 1,000,000 of these lists. We'll repeat this test by making 1,000,000 tuples.
Tuples.
Finally, we will display the 2 times.
Okay.
Run. On a
so the tuple time. So this is a list. So the difference is I'm seeing as a square bracket, and this is regular bracket. Is that the difference?
relative basis, it took much more time to make the lists than the tuples. Imagine the time difference when working with billions of pieces of data. By now, you should be convinced that tuples are useful.
Gosh. We're going to have to watch this. Okay, this is the last one. All right, Sean.
Hello and welcome to Chapter 10. Now we're going to talk about our third kind of collection called tuples. But tuples are really a lot like lists. There's not too much to them. They're really kind of reductionist version of lists. So they function very much like lists in that they have things, and the difference is there are no square braces. There is a parenthesis, round brace, or whatever, and they have positions 0, 1, and 2, just like a list. And you can look things up, x sub 2. So x sub 2 is actually the third element here, and so that prints out Joseph. You can assign, make a tuple here. This is the constant syntax for a tuple, and print that out. And the print statement shows you that this is a tuple, not a list, by showing you round parentheses. And a whole bunch of functions that work with lists work the same way with tuples. You can put a tuple at the end of an in statement in a for, as you might expect, and then it iterates through the tuples. Tuples maintain order, so it prints out 1, 9, and 2. So literally, this bit of code here could be identical whether it was a list or a tuple. It really would do the exact same thing. The difference between tuples are that they're immutable. Once you create the tuple, you can only sort of assign a tuple, but you can't modify. You can modify a list. So if we take a look at a list here, we make a list that's 987, and we say x of 2 equals 6. Well, that just means this 7 becomes a 6, and that's just natural. Meaning we can reassign slots. We can delete things, we can insert things, we can mutate them, we can change them. So they're changeable, right? They're changeable. But if we try to do that same thing with a string, so we say y equals ABC, and we know that this is position 0, 1, and 2, but if we try to say, let's change the C to a D by saying y sub 2 equals D, that is not allowed. And it says it doesn't support item assignment, and this little bracket, x sub 2, is what they call item assignment inside of Python. And so if we do the same thing then with a 3-element tuple, put that in Z, and we try to change the slot to be a 0, it's going to blow up, because it's the exact same thing. And that has to do with the fact that once this assignment is made, this is not modifiable. Now, it turns out that the reason it's not modifiable is for efficiency. They take up less storage, they are quicker to access, and they're really designed internally behind the scenes in ways we don't really need to understand. They're just more efficient than lists. If all you want to do is store a list,
list and look at it and then throw it away, you probably should use a tuple instead. So there's a lot of things that you can do with lists that you also can't do with tuples, but they're really just a corollary of this notion of non-mutability. And so like you can sort a list, but you can't sort tuples. You can add a 5 to the end of 3, 2, 1. Can't do that in a tuple, but you can in a list. And flip the order. ... So anything that you can do to a list that modifies the list, not allowed for tuples. And so you can take a look at the kinds of things that are inside the methods that are part of each list: append, count, extend, index, insert, pop. Many of these are modifying, and then count and index are the only ones that work for tuples. And so tuples are limited lists. Now, at some point, there's going to be a but here to say, why do we like them? And the reason that we like them is that they're just more efficient. They don't have to build Python in its own internal organization of these objects. It knows that they'll never be modified, because when you make a tuple, you as the programmer are saying, I'm never going to modify this, and Python won't let you do it. So it's high performance, better memory use, and to a beginning programmer that doesn't really matter, but that's the reason. And so we tend to use tuples when in situations where we're going to make a temporary variable and then temporarily use it just a little bit and then throw it away without really messing with it. And we tend to use lists to build things up, et cetera, et cetera, et cetera. So the other thing that's interesting about tuples, and we've actually sort of seen this, is that you can put a tuple that includes variables on the left side of the assignment. And this takes a little getting used to, but it's really cool, and no other language that I know of does this. So if we say x comma y, that's a 2 tuple. Both have to be variables. You can't put constants on this side. It's like saying x equals 4, y equals Fred. Right? So what happens is you can put a tuple on the far side of an assignment statement. The 4 goes to x, and the Fred goes to y. And you say, what's in y? Well, y is indeed Fred. And so this is like 2 assignment statements. Now, the way I've got this syntax, I would probably do 2 separate statements, just not to show off that I know how to do tuples. And so here's another one.
Okay, hang on here. Tuples and assignment. We can also put a tuple on the left-hand side and an assignment on the statement. That's interesting. So it's almost like you're assigning X is now 4 and Fred is Y. Okay. That is wacky, because I thought that contradicted what he was saying at the other time, that we were modifying, but we're not. We're assigning.
And they just move correspondingly. If you don't have 2 here and you do have 2 here, well, if you have 3 here or 2 here and 3 here and you don't match the number there, you get in some trouble. Now, if you just say x equals tuple, then that is the tuple in the list. But this is just a simple straight 99 value going into A. So you can put tuples as the left-hand side, and you can even do things like return a tuple from functions. That's a real nice Python feature that I like a lot. Tuples are also related to dictionaries, as we've seen in the previous chapter. So here we make a little dictionary. We make an empty dictionary by constructing an empty dictionary, stick it in D. So D is sort of like this place that can hold key value pairs. And we put CSEV, and there's a 2 in there, and chen-wen, and there's a 4 in there. So we have this associative mapping between C7, 2, and chen-wen, 4, all stuff we know. And now we say, hey, we're going to loop through the key value pairs here, and we've seen the syntax before, k comma v. So this is a tuple. So you can think of this as each one of these things is going to get assigned into this tuple, which means the key ends up in the first one's the key and the second one's value. I use the variable key kv all the time in code that I write, just for my own sanity. So kv are going to iterate successively through the successive keys and values in that. So this is going to run twice, and k is going to be CSEV2 and chen-wen 4. The order just happened to stay the same. And so if you say what is in one of these things, you can actually take d items, the items method within that dictionary, and say, hey, give that to me back, and then print tups. And it's a special kind of a class, but really ultimately it is a list of tuples. This is 2, this is the 0, and this is the 1, the first and the second. And then within each thing you get, you have a 2 tuple. And so in a sense, this k and v are iterating through those things when we're putting d items here.
Okay, so yeah, this is wacky here. So okay, let's see if I understand this correctly. So d equals dictionary, and then we put the 2 and a 4 in there, and then we say for so k and v. I guess he likes those because they stand for key and value, but okay, whatever. So in d items, print the key and the value. Okay, I see. The items method in dictionary returns a list of key value tuples. Okay. So items is a method.
And the items there. One nice thing about tuples is that they're comparable. They're comparable in the same way that strings are comparable, meaning that they're compared from left to right, with the leftmost or 0 tuple being the most significant. And it doesn't compare any further than it has to if it's asking less than. So if it's looking at, say, this first tuple, it starts at the left and says, okay, it asks the question, tell me true or false. Is 0 less than 5? The answer is true. And so the answer to this overall expression is true, and it doesn't even compare those 2 numbers, or those second and third number. They don't compare them. If, on the other hand, we're asking is this less than that, it only looks at the first one and asks if it can answer the question. The answer is, well, they're both 0. And so I can't answer the question, so I have to go to the second one, second pair, and 1 is less than 3, and so that means this is true. And it does not check this, even though 20 million is bigger than 4. It doesn't matter, because these are the numbers that cause the true to happen. And the same is true if you do this with strings. Again, we start the first one. So Jones, Sally, well, that's the same, so we don't know the answer yet. And so Sally, Sam, well, okay, S, well, they're the same. A, they're the same. Oh, L and M. L is less than M, so the actual letter that makes the difference here is the L and the M, and leads to us being true. And so it goes left to right, but then even when it's doing strings, it's going left to right. That's just how string comparison works. And if we say, is Jones Sally greater than Adam Sam? Well, we check the first one and we check the J and the A. Well, J is greater than A, and so we don't have to look at anything else. We don't have to look at any more of these characters. We don't have to look at the second thing in the tuple. We have to look at that is enough to be true. So it only scans until it has a definitive answer. It doesn't scan any further. So now what we're going to do is use this comparable capability to sort these listed tuples and then bring this all back and connect it more to dictionaries.
Okay, so we can probably answer the question now. I was getting a little confused. I hate that, especially when it comes to jargon, you come to words that are similar to what I already memorized. The one I was getting confused with was tuple if statements. Not tuples, but truples. I don't know if I'm spelling that right. Difference between, geez. Is it triples? Triple if statements. I'm gonna have to find the correct. I thought it was called triples too, or it looks similar to that. But what I was thinking of was, and this is not to confuse you. This is just to confuse myself. But you can write in some languages. You can write an if statement like if if 10, then then do X. They'll be like that. Like they'll just use. And I thought this was called a tuple. So you have like a if then statement, but it's on a single line. And the only like you basically you check something and then you do this, and if not, then you do the right hand. Like yeah, kind of like that. Exactly. Yeah, kind of like a flow. I don't know what the heck that was called. If it was like if statement with a colon. With a colon. Statement with a colon. Somebody had the same question here. Yeah. Anyways, this is off topic. I'll have to look that up later. Find the proper jargon. So going back to our question here, and this will be the final one. We'll wrap up. What will the following code print? So we know for key and I, instead of key and v, I think it's going to go through the whole list. And it's just going to list out the values, in which case it's going to be 1 for Quincy, 5 for Bo, and no, sorry. It's going to be that one, right? It's going to be key and then value. That's what I think. And there we go. Boom. So we've already chewed through almost 50% of this certification. Yeah. So it was a productive night. I learned quite a bit. I hope you did too, Sean. This was a fun get together. Thanks for showing up. Maybe there'll be more people next time. Yeah, absolutely, man. I had a blast. I hope you have a good weekend. And if you're okay, can I post this online? I know we have a recording. I don't know if you're okay with that. Of source. Of course. Okay. All right, man. Thank you. I appreciate it. And if anyone's watching this, thank you for watching. I'll talk to you, man. Bye. Let me kill the session here. All right, man. Have a good weekend.